something.
Okay, this isn't quite the way you... I think if you write it this way, we'll see. Because I'm not fully sure actually which way is the correct way to do it. I think this way, like it might still give a warning about like it being like a signed to unsigned cast. I don't think it would though, because I'm pretty sure the concatenation operator lets you convert from signed to unsigned already, so I don't think you have to do a cast. But no, like this is so in general, whenever you're doing like a lookup into a bit stream, like something like this, and this expression here is not just an identifier, like say it's like j plus j or something, you have to use curly braces around it because system Verilog is weird and they designed it weird. So you have to do curly, like you can't just put parentheses around the j plus j. It has to be curly braces because you have to use like a concatenation operator
Mm.
because like doing an array lookups can only occur on identifiers or on the concatenation operator, and that's it. Um, there might be one other that I'm forgetting about, but I'm pretty sure that's it. Like you might be able to do it on the replication operator too. Might be wrong on that though. I'd have to check the manual. But yeah, let's see. So you initialize it to 0 through there. Initialize the ready bits to all high. Is that a 32-bit? Let's see. That's 410. Yeah, no. I guess you could have just done apostrophe F, but or apostrophe 1. But that works
One.
too. Um, if we're doing
I just think of the
restore,
first thing I do.
so yeah, so then if we're doing restore, we do that. And then, let's see, if write port.write, then we set that, and we update the ready bits, which the ready bit gets cleared for the write port. And this uses the old value from the rat table, which is correct, instead of the new value. So yeah, I think that's correct too. Yes, I think that's everything. As long as there aren't any signals missed, which I don't think there are, because that's just you just have read ports, write ports. I don't even think the read ports have any control signals, unless I'm forgetting something. No, yeah, no, it's just yeah, okay. Yeah, I think this is everything. So then we need to go in to the RF, tweak this one slightly. So let's see. So we have the RF table. Track the old physical register that needs to be freed. Okay. Provide all the mappings to the RAT. Yeah, that's fine. And I guess the other thing is we want to forward the restore signal from the ROV. So there's a rat ITF dot restore equals rob ITF dot restore, I think. Yeah, I think that's everything. And then so let's see. So we do that. We have the old physical register, which is whatever's currently in there. And so we want to push when the stuff coming in from the rob is valid. Here it is. Yeah, so when that's valid, and that's equal to 0, or that's not equal to 0, And then the data in is the old physical register. And then we initialize the RF as just 0 through 32 or 31. Oh, and then here as well, this also then needs curly braces. And then, so when route valid, so then we update that. I believe, yeah, I think that's everything that the RF has to do. Yeah. Let's see, so RF free list, we have push, we have full. Full you never have to use.
But yeah, it's
Yeah,
there.
yeah, it's there. But you have to use it because the free list by design,
It
like we
shouldn't be
never,
ever
yeah,
be
like you
full.
never have to care about the full signal, and you never have to care
But
about the empty signal
it,
either.
I have a full signal.
But
I
yeah,
may as well have it be used.
yeah. I mean, potentially in the future we could like do an assert statement or something, so that way at least during simulation it checks like, oh, we're not trying to push while it's full, sort of thing. Um, but that's probably about it though. But yeah, so this looks correct, and then let me go back in here. Let's see, so I have the RF interface here. So I set valid, archreg, physreg. Um, Here it is, valid, archreg, physreg. And so I just need to set restore. So for now I'll just set this equals 0. Because for now we just never want to restore. In the later, I'll just put it to do here. To do implement mispredict. But for now they'll just be 0. And then let's take a look at the free list. So this one, I think I'm going to get rid of this parameter if that's okay with you. I'm just going to change it to use the one from the types.sv. That way there's less chance of bugs. Where we forget, we like update one parameter but not the other, sort of thing. Let me double check what I named it. Yeah, so I think what I'll do is I'll just do local param numphys regs equal to nphys regs, and then get rid of that, and then I also need to change it here too then. Yeah, and that's sufficient to change it over. The nice thing is you can just do a local param and there's no issue there with doing that. It's just now you can't. Now the idea is you can't like try to parameterize the model either, or the module. But yeah. Does it actually complain about the width mismatch for this? I'm kind of surprised. You'd think it wouldn't care for this thing. But, yeah, I guess maybe it would. Um, but anyway, so this numphysreg minus 32. Oh, you did update this. Oh, thank you. Thank you, Indy. You already did this
Yeah.
for me. I was thinking I was gonna have to do this myself.
Yeah.
You already updated it so that way 0 through 31 are already in use. Cool. And so then, let's see, does the head and tail pointer point at the correct spots?
I'm not
Although
sure.
actually, I think the 0th one we don't need to be, or the 0th one we can mark as free as well, I think. Because otherwise it's just never used, but yeah, I think, because like if you think about like what happens to the 0th physical register currently, it basically just stays assigned indefinitely to architectural register 0.
Mm.
But then we also do checks, or we do a check in the reservation station. If the source register, like the source architectural register is 0, we just always return 0. And so we don't actually need to keep around the value of the 0th physical register. Therefore, we can actually indicate that it's a free physical register. So let me think through how you would actually. Also, this needs to be like that, probably. We'll see if that actually. I don't know. We'll see if that works. I think it's synthesis that complains. I might be wrong, but I'm pretty sure it's synthesis that complains about like the signed to unsigned um, cast. I might be wrong on that, but I'm pretty sure. Like, hopefully, this gets rid of those warnings, like doing curly braces like that. But anyway, let's see. So how would you change it? I think what you would do is how'd you do it? Also, see, like, I don't know if the head and tail are correct here. Are they? Or, no, yeah, because you start off at 0. Okay, yeah. And then... And so then head corresponds to... So tail is where it pushes stuff. Head is where it pops stuff. Let's see, so then it sets that, and then it increments it. And... Okay, so that's just a queue, that's that. Yeah, the trickiest part is just the initialization state for these. So I guess I could do, let's see, so I could do free regs 0, assign that to 0. And so then for here, we'll do 1. So then for 32, it'll do 32 minus 31, which will then put it in the first register. And it'll put in 32 up to num phys reg. And then... I mean, technically, it's good practice, I guess, to set the remaining ones too, maybe. Which, let's see, so the remaining ones are... Oh, and so then... this should be minus 33, right? Because the total length is... Or no, we have one more, so 31. Yeah, because we only reserved 31 of the registers.
Yep.
And so then, let's see, so then for setting the rest of them to unknown, which isn't strictly necessary unless you reset the CPU multiple times within a simulation, that's when it's useful. But like if you're only doing a reset at the very start of simulation, it doesn't actually really matter if you set the rest to unknown, but might as well. let's see. So then the first index will be numphysreg. So we already did numphysreg -1 -31. So now we want to do numphysreg -31 up to numphysreg. So I think it's those. I think it's those ones. I mean, I guess this is something that we might want to verify, just like within Verdi, make sure the free list is getting the correct list of, like, making sure it has the correct initial state. Um, but yeah, I mean, I think this should be sufficient though. I guess like instead of doing this, I could alternatively just set all of them to unknown, and then. Oh, actually, wait, yeah, I could just do that. Never mind. Yeah, I don't even need to do. I can just say because it's a packed array, I can just do that. Set all of them to unknown, and then set the 0th one to 0. Um, but yeah, so then we set the 0th one to 0. Then we set the first one to 32, and then we continue going up all the way up to the number of physical registers. Okay. Yeah, so I think that's everything then. Yeah. I believe that's everything. So then, let me just double check. So the RAT, yeah, if it's equal to 0, we always return 1 for the ready bit. And likewise there. I think that's everything. So I think at this point we just need to connect stuff up.
Good.
Do we want to divvy up connecting the modules together? Or like, does someone else want to do that? Because like, we already have all the interfaces, so it's just a matter of like defining them where necessary, and then just looking at the module ports. If you want me to, I can do it, but I also want to work on the like updating the randomized assembly generator um, in order to support the multiply. Although I guess that won't take that long to do. Let me actually just
What do you want to do?
start.
I'll do whatever.
I don't know. If you want to, you can start connecting things together. At least the nice thing is like all the interfaces are labeled,
Mhm.
and so there isn't really too many mistakes you can make when just connecting everything up within CPU.sv. But yeah, because all the interfaces are labeled. So it's just a matter of like declaring all the interfaces. Oh, and also like, so the way you declare the interfaces is just like this. So you do need to specify .clock and .reset for all of them. I'm pretty sure all of the modules have a clock and reset. I don't think there were any that didn't. I can just scroll through and make sure they all do. Yeah. Yeah, it looks like they all have clock and reset. So the syntax is basically just always going to be this. And yeah. And you don't even have to specify. So since we already specified the mod ports, like within the modules as well, so that's one thing that's not strictly covered in here. But since we already specified the mod ports for every single one, I think, I'm pretty sure we did, You don't actually have to specify the mod port in here, so you can just connect up the interface as like dot port name, and then you just put in the name of the interface without specifying the mod port. Because like the way you specify the mod port is you say interface instantiation name dot mod port name, but I don't think you have to do the dot mod port name because we already specified it again within the modules themselves. Um, yeah, and if there's any spots where we didn't, we should go back through and actually specify it because that's how you specify the input and output directions for the interface. But anyway, um, yeah. So if you want to, if you want to, Indy, you can start doing that. Also, let's see. So there was also the. Wait, where were you doing the progress report actually?
Um, um, and the documents in Google Docs.
Is it where is it? Let's see. There's the checkpoint one progress report, which I think you just directly, or maybe directly shared with me or something. Let's see. This one has. Yeah, so I don't even think you should. If you want to, you can put it in the folder, wherever it is. This one. If
I
you
don't
want
know what to
to,
do.
if you want to, you can move it to the block diagram. It's up to you.
I'll
Because I
update the
think
block diagram.
what?
Wait, okay. So what's there to do?
Um,
Connecting the stuff up, right?
yeah, two things like connecting the stuff up. There is like if you want to, you can put like the progress report within the shared drive folder. Um, which I think yeah, it's just us three that have access to it. Yeah, so if you want to, you can put it in here. We
Yeah.
might even be good to actually move the first checkpoint one in here as well. But um, and then
Uh,
I'm gonna work on the randomized test bench, updating that.
I think
Let's
I
see.
might start try and connect everything up.
Actually, wait. Let me commit stuff first, and then you're gonna want to merge my branch once I push it.
I love. Should I merge that to main? Just yeah, like after you merge. I mean, sorry, after you.
If you want to, you can do it on. You can work on main. Yeah. Let's see. So I'm gonna let me first commit all this.
There's only two branches we have to worry about, yours and mine.
Yeah. Yeah, because I already merged Yunq's branch in. Um, yeah. So now everything's been merged into my branch. There's no unmerged commits at the moment, so you should be able to just merge it into main without issue, and then you can just work there.
Okay, let's do some merging.
Now I have to remember which version is the one that I want. Me when there's 3 different versions of this random assembly generator. How did this one work? Oh, okay. It's not this one. This one I think I gave up on. I was trying to do some fun static analysis stuff,
Really cool.
and I ended up giving up on it because it was taking too much time. I'm like, I am not gonna bother with this.
Okay. Git merge. Let's see. I'm gonna delete this. I don't need- What else is on track? Reservation station. I delete you too. Oh, that's right. It's called rstat. That's so weird. That's fine.
What? It's a good name. It's
Yeah.
different enough from everything else that you won't confuse it with something.
Yeah.
That's why I did it that way. Because everything else, like, what? RST? We already used that for reset, you know?
I think I don't have anything else that's okay. I guess I'll merge it to main because I didn't add anything to my branch after you started working on that.
Yeah, like, there shouldn't be any addition, like, there shouldn't be any, like, merge conflicts or anything. Like, I already merged your branch, and
Git
unless you
checkout
did
main,
some
git
other...
merge main, git merge your branch, git status. Okay.
We love argparse. Yay, Python. I mean, hopefully the code is at least somewhat readable. If you guys want to read through the randomized assembly generator just like at a later point, it's potentially good to understand. I mean, there's the one that I was in the process of writing that I'll make sure to get done for the next checkpoint because it'll do a lot better job testing loads and branches, or like load stores and branches, because this one doesn't really do that good a job at all at testing them. Yeah.
The arbiter in here. Oh, it's literally called CDB arbiter.
Oh yeah, I guess that is. So that is one thing. Make sure that the indices of the function units match the indices as they're like defined within types.sv. Namely, the rstat types here This is basically, this is giving the type for each function unit, so make sure you have index 0 be the ALU, index 1 be the multiplier, and index 2 be the divider. Because this is used by dispatch to figure out where to send a given instruction, so... I should actually make dispatch round robin, now that I know how to do it correctly. I should actually make dispatch round robin as well. Or... maybe. It's not necessary for this MP, so whatever. Because, I mean, there isn't really any point in making it round robin because there's only a single function unit at the moment that a given instruction can go to. Like, either it goes to the ALU, or the multiplier, or the divider. There's no overlap. So... and there's only one of each type as well, so... for now, it doesn't make a difference. In the future, when we have more function units, it probably will.
It, uh, uh,
Oh, I guess it lets you input in a subset of the full... okay. Strange. Okay, so the name to check for is that, though. Yeah, this is another nice thing about this generator here. It allows you to limit the number of architectural registers that it uses, which allows you, at least for MP pipeline, it allowed me to like test forwarding under different conditions, which is kind of nice. Or not forwarding, hazards under certain conditions. So it might actually be good to like tweak that value and try lowering it. We'll see. Actually, how do you declare? So this is one thing. It's like, how do you declare an array of interface instantiations? I take a check. Let's see. So you do. Let's see, which section is this in? 2332. Okay. Yeah, so I'm pretty sure like for the spots where you need like an array of interface instantiations, um, you can use a syntax like this. Like it's the same as like declaring an array of module instantiations. Yeah. Yeah. So it's the same syntax though. I guess it's not strictly needed, but it'll make connecting up the PRF easier at least, I think. Because then you don't have to individually specify like both of the read ports for the PRF, like for each function unit.
Oh, what am I doing? Oh,
Actually, wait, does li work? Okay, because the random assembly generator here uses li. Um, I'm pretty sure li is okay. Actually, let me go back and check to see what the disassembled code looked like. Um,
Pause it.
Never mind, because it didn't. I guess I cleared it out at some point, but. Yeah, I guess I cleared out. Yeah, I must have ran like make clean or something on it. Strange. We'll also have to hook up the RVFI signals too. Although that should be pretty easy because it's just like you take the outputs from the ROB and you just use that, and that's it. At least I think that's it. Let's see. I take a look just to make sure. Yeah, because there's an RVFI valid and an RVFI out, which includes everything else. So, yeah. Let me double check that all the RVFI fields are populated correctly. Let me check that. Let's see, because there's 9 total. So we set the instruction word. We have the address. Oh, and this works out too. Okay, good. Because like there was that change that I made where it's like if RD is equal to X0, it marks it as being not used, but that's okay for RVFI because then it just sets the architectural index for RD to be 0, which it already was 0. Okay. Yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? How many RVFI fields are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh, wait. Okay, that's another thing that I should do. Let's see. So if we look in decode, yeah, because instruction queue has the RVFI packet in it. So let's see.
There's so much.
Okay, yeah, so the RVFI there, and then so first off, how does CPU.sc initialize the queue? Okay, so it just uses bits there, so that works. And then I think I need to modify fetch. Yes, because I don't think we've actually updated fetch to set this down here. Oh, how do we want to do this? Yeah, this is this is something that we need that has not actually been done anywhere else. Like we have to basically set the order field of RVFI in here. Let me do that.
Sleepy going. There's so much corn.
Actually, I think I only have to set a few of the fields here, and I think the rest will get set in here. The fields I need to do are... Let's see... I do all those... Okay, there. I think I've updated fetch to now properly populate the RVFI, like the remaining RVFI signals. Because I forgot to do that earlier. Hehe. At least the instruction queue already seems to... Like, I didn't have to make any changes to CPU.sv or anything.
Mm-hmm.
Let me actually double check that I didn't. But, like, the instruction queue already is just parameterized based on, like, the number of bits within the data type. So, I didn't actually have to make any changes. Yeah, all I changed was fetch.sv. Yay. Anyway, here I'll just check the RISC-V assembly manual because I think it says what the pseudo instruction compiles to for load immediate. Load immediate. Okay, load immediate compiles to an LUI and ADI. I mean, it wouldn't really make sense for it to compile to an AUI PC anyway, so yeah. And then let me double check that there aren't any branches or labels or anything where it might try to use. Right here, I'll update fetch.sv. How's it going?
There's too many things.
Yeah, Yeah. I don't know. I mean, like, are you just doing it by like going through the block diagram? Because that's how I would
Yeah,
do it. Like, just
that's what I'm doing.
start off from fetch and just start adding stuff in, like, kind of
Yeah, that's what I've been doing.
breadth
But I'm
first
just like,
search or depth first search or whatever. But yeah,
I started from. Oh my god.
but yeah, just remember to like instantiate both the modules and the interfaces, as well as like have the signals for like the CDB, the RVFI, that like because like the RVFI gets output from the ROB directly, and what's the other one? I thought there was one more that is not an interface. The CDB, ROB, or CDB, RVFI. Actually, that might be it. Yeah, I don't think there's anything else that's not an interface. I might be wrong, but I'm pretty sure. Oh, also the free list. That's the one that. Although the free list there's an interface for, so you can still define that one as an interface, and then just
Oh,
like do a reference into it when you instantiate the free list.
wait, what? I think that's everything. I can't.
Yeah, because it's the same three signals. So
Okay. We have until up to decode. Sorry, up to instruction queue, right?
yeah, we have. Yeah, I think the existing CPU.sv already has everything up to the instruction queue. Yes, I guess that's another thing I should go modify. Let me modify the test bench as well, and like remove the code that like drives the queue from there, because we'll have to do that before we can test it. Let's take a look.
How do you do the decode with the double thing?
What, the array of
Yeah, can you
interfaces?
just do like decode rat read one? That
Okay,
decode.
so the syntax for it, I pulled it up earlier. So it's the same as if you do like an array of module instantiations. So it looks like here, I'll just copy it from the LRM. It it looks um like that. I guess like in this case it would be like, let me double check. It's, so let's see. So we want T code rat read. And we want two of them. I think you do that. Or wait, no, not that. You have to give it a name as well. um, there, something like that is how you would do it. And so then it just declares like an array of instantiations or interface instantiations. So it's just like array of module instantiations. Yay, 385. Yay.
I love it.
But yeah.
You know, I'm starting to appreciate this interface
This is
thing.
why I did it. It is a lot less typing in CPU.sv to have interfaces.
Yeah.
Because I knew, like, there are so many edges in here, we are going to need interfaces. Because it really helps with organizing CPU.sv, you know?
Yeah. Yeah.
But yeah. That's why I was like, so, like, please use interfaces. It'll be a pain later if you don't. But yeah. Let's see. So I think the random assembly generator is good. Right now, I'm just writing a test bench that just tries to test all of the different like corner cases um, for um, the multiply and divide instructions. So I'll probably like basically I'm creating a set of edge case values right now, and then I'll just basically like probably write some Python that just lists off every single combination of multiplying one of these or you know like one of the 8 possible you know m extension instructions and just have one of the operands be one of these and the other operand be another one of these, which in total will be 8 times 6 times 6 to enumerate all of them, which isn't that big of a number. So yeah, it'll be a long test bench, but it'll at least cover every single edge case. So yeah. Let's see, are there any other edge cases? I have max unsigned int, i.e. -1. I have max signed int, minimum signed int, minimum unsigned int, which is 0. Um, just some random positive value and some random negative value. I think that's probably sufficient. Because like the random assembly generator will already test, you know, different combinations of like positive and negative numbers. This is just to test like the edge cases of like 0, -1, max int. I mean, I guess I could add in 1 as well. Maybe I'll do that. x6, 1. Because maybe that's another one that would be good to test. But yeah.
Please stop. Water bottle.
You having
Where's
fun there?
this? I just like technology. That's all.
Yeah.
Where's CDB packet comp? Oh,
CDB packet comes from the arbiter. Yeah, and
okay.
then it goes
That's. I
to
was a little bit slow on that. I'm just like, what is going on?
yeah, it comes from the arbiter, and then it needs to go to, let's see if I can list all of them. The ROB, the RAT, not decode, although I would double check that, but I'm pretty sure decode doesn't need it. Um, dispatch needs it. All the reservation stations need it. Um, I think that's it, but I might be wrong. Like basically, your job is to just go through all the files and look at the different ports for the modules and make sure you're covered. Like as you instantiate each module, make sure to like connect up every port that's listed. But
There's
yeah.
so much. Uh,
Yeah. Hey, at least it's better with interfaces.
it's a little bit better. I'll have to admit.
Yeah. Realistically, we probably should have connected stuff up like as we went, but
That's
I don't
fine.
know, it's not that big a deal.
Am I still Kyle. Kyle there. The rafting. Ducky. Shit. Oh, how do I do the preservation station?
Which part of it?
There's 3 of them.
Yeah, so you're gonna want to instantiate the 3 modules. You don't need to do like an array of ALUs or anything because we're just gonna have one of each. Um, and so then when you connect it to dispatch, so the way you connect it to dispatch, let me pull up, let me make sure I remember correctly how the port worked here. Yeah, so the way you connect it to dispatch is you use like a syntax for the port that looks like let's see. Something like that. So you just, you declare like an
What
unpacked
is
array.
that?
Yeah. Yeah. Um, and then for the physical register or like the PRF connections, um, you can do something similar for the PRF. Let me look at the PRF just to see how that one was. Yeah, okay. So then for the PRF you do
There's so many.
so for the PRF, you would do something like that, and notice that you don't actually have to index into the like array of 2 PRF ports. You can just pass the like pair together. because it's like a multi-dimensional array for the like rstats port on the PRF. Like first it's indexed by the number of rstats and then it's indexed by 2. So it's a number of rstats by 2 port. But yeah. So you don't actually have to like index into the array of interfaces. You just pass it.
Whole bunch of- Okay, so then we want to.
Thoughts on my test bench?
I am typing away. Oh wow! What a great test.
Oh wait, no, I messed it up. Hold on, wait. There's a bug. How did I do that? Oh, I forgot a comma. Yeah. But yeah, yes, just try every single combination and make sure all of them work. We love edge case testing. Hopefully this doesn't take too long to run. I don't think it would. Again, it's only like, let's see, there's 7, so it's 7 times 7 times 8. Here, I can actually just print out.
My brain is melting. There's so much going on. let me know when you want me to, because we're gonna get into a lot of warnings and stuff. Um, do you want
I mean, I'll
connection
start
stop? Because I'm
debugging
done.
it this when you're done. What?
I'm done.
Oh, you finished? Okay. Well, so I'll just finish this and then I'll start the debugging process. Let's see, we got 2.5 hours. That's probably enough time. What did they say? Allocate 3 days for debugging? Psh, can do it in 2.5 hours. We'll see, we'll see. But
All right, good luck. I think it's okay.
it's only 512 instructions that it generates then. Or wait. No, hold on, hold on, I didn't do this right. I'm just gonna change this here. 392 instructions. I don't know, are there any other edge case values that you can think of that aren't in this list here?
No.
I got 0, 1, -1. I guess I could add like 2 and -2. I don't think that would really test anything though that isn't already being tested. Yeah, I don't think it would. But yeah, I got like max signed, min signed, max unsigned, min unsigned. Yeah, I think this covers all of them. But yeah.
Zenrex. I need Riz.
Okay, good. You're You removed the assignment that used to be there for the decode instruction.
Of course.
Good. Imagine leaving that in, would be an error because it's assigned in multiple spots. Yeah.
Multiple drivers warning. Let's go.
Yeah, so you didn't have to specify the mod port for all of these.
I just went with the like. I still don't know how to use these things. I kind of just
Yeah,
follow
it's
the
okay though.
pattern.
I mean, it still works, and it's a bit more explicit as well, so like it might give better error reporting, I guess. But anyway, so you do num slots for multiv, lu. Okay. So these ones down here. Well, okay, some of them you do, or the ones that are arrays you don't use the mod port. Which, yeah, I'm not sure if it would even let you, so that's good. um, Nice that you added these comments to at least somewhat organize it, because I personally would not.
Yeah, like
I would have just gone through and listed all of them out and not bothered to organize it.
there was a point where I'm just like, what did I write? I don't know what I wrote and what I forgot to write. So I'm just like, okay, I'm doing this. All right, good luck. I don't know how I can help.
Wait, does the PRF need a CDB? I don't know if hold on, let me check if the PRF needs one, because it might not, actually. Let's see, PRF.
It
Oh, it
does,
does.
only because I'm looking
Oh,
at the
right.
diagram.
I forgot that the whole point of the PRF is that it reads off the result and puts it in the
Yeah.
hee.
I'm just going off the block diagram, so
Yeah, or at least like also like, did you like pull up the module to see like what ports were listed to as you were doing it?
yeah. So my
Okay.
workflow is like I pull up the functional unit, and then I see the ports, and then I see what I need to do, and then I put those two together, and then you have it connect.
Yeah, okay, that should be pretty foolproof.
Yeah.
Um, I think. Yeah, and so then you index the specific fields there. You clock and reset for those because they take separate clock and reset. Okay. Okay. That probably is sufficient. We'll see.
I'm gonna cry.
Let's see. So yeah. So let me, because I've pushed all my stuff, right? Yes. So then
Right
I
on
will.
me.
Yeah, I'll go over. Do I just work on main from now?
I think that's all we can do, right?
How do you switch? Oh, it's get switch. It's get
Kick
switch
branch main.
main.
Let's make main two. Did you like main one? Well, we made main two.
Yeah, we're making a second main branch. Okay. Yay. gonna run lint first. Lint with fatal. Tons of syntax errors. So let's see, so there's a couple of these. Time to use Vim nested in Vim. Yay. See, if I was smart, I would actually just be going in each file and fixing things, but whatever. Why is Lint giving me warnings? Man, Lint is giving me errors about the assigning like an array of interfaces. And I'm not sure what the correct way to do it is then. I think I'm gonna try looking it up to see like how are you supposed to assign like an array of mod ports? Because it's not liking it either way. Like if you specify the mod port it doesn't work, and if you don't it also doesn't seem to work, I think. So I'm not sure how you're supposed to do it. Yeah, we'll see. Maybe you're not supposed to use mod ports, like an array of mod ports as a port definition? That's annoying though, because then it doesn't... Really? I'm looking it up and it sounds like... Yeah. I guess I'll try a couple things, see if any of them work. Never mind, I guess we can't use multi-dimensional array of interfaces. It's just unsupported by synthesis. Lol. Lamau.
What do we do? What do we do now?
We do a single dimensional array, because it sounds like at least single dimensional arrays seem fine from what I'm reading here. Non-static access? Oh, what's that one in? CDB arbiter. Ah, that's fun. So I'm gonna have to rewrite initial declaration at assignment for index is ignored by synthesis. Interesting. Anyway, what else we got in here? FUTAVE, operand bit mismatch for operator, and oh, okay. Warning, function units, ALU.SV, input clock declared but not read. Ah, yeah, because we never use those. Okay. Let's see, I'll work on these first. So, first of all, select on concatenation, which I think is the trick that I tried to do to get it to work. I guess we can't actually use that trick. Which, fair. Well, I'm surprised it doesn't support select on concatenation, because I feel like that's not a terribly difficult thing to support, but whatever. Whatever. Anyway. Oh, that's fun. So you can't even use... okay, that's fun. I guess it's not terrible to get around, but... Alright, let's see, so it's, non-static access... Okay, an interface array is not supported. So saying line 54 is an issue. Interesting. So are you supposed to then use gender maybe? So how do you do generate blocks again? Generate, yada yada. Right, so you do 4. So you don't need generate. Okay, yeah, so you can just do this. Let's see, so does that fix it? See what it gives now. See, a lot of this is just the linter does not like some of the system verilog constructs. Lol. Which, fine, sure, whatever. The fuck you mean? Logical implication binary operator is not a supported SV construct? Crying, what? Wow. They really just did not want to do that one. Anyway, so non-static access rstat I.ready. Okay, so you have to basically split it out into an array. Okay, that's a little annoying, but it's manageable. It's just a little bit annoying. But yeah. I mean, honestly, it might have been a better idea to actually use, instead of using interfaces, to actually just use packed structs, and then just have like a pair of packed structs for each interface, like one for all the signals going one way and another for all the signals going back. It honestly probably would have been better to do that, because interfaces are not supported that well. But it's fine. Yeah. It's just like, some parts of interfaces are not really supported that great. Anyway, let me go and fix the rstat issue, I guess. getting this round robin CDV arbiter to synthesize is not easy. The method that I thought you could use for it, it doesn't work because it requires a combinational loop, which means it doesn't. Like, it requires a combinational loop to work. I might honestly just forgo round robin for now, just because it's a pain to get working. It feels like it should be possible, but yeah. I don't know, is there any other way to do it? But yeah, because like the way I was originally thinking would require a combinational loop, so it's not going to pass lint. Is there any other good way to do it? Not that I can think of. No. Yeah, no, I don't. Oh, what? How do you do a round robin type thing? I don't know. I'm just gonna change it to not be round robin for now. Because this is already a pain to get working. Yay, lint passed! Finally. Okay, so we're passing lint. The question is, are we passing synthesis? Or not synthesis, sim. Forbidden keyword table. Ah, we love forbidden keywords. Let's see, so we have rat.sv. It's so annoying that it's like
That is
you have to use like
funny.
Yeah, it's like anytime you put the word bit in a comment, it
I
gets
love
mad.
comments.
And so what I ended up doing, at least in previous ones, was just like put a dash in the word bit. Let's see, what's the next one? Okay. There's ready bit. Yeah, right there. But yeah. At least by going through, oh, there's more. The swap file. Grr, fine, I'll close Vim. Grr. Alright, but yeah, since it passes lint though, it should, oh, never mind. No such file for that. It's not terrible. Oh, is this the annoying part where like you have to grab all of the like, yeah, because someone was mentioning this in the Discord. You have to like grab all the transitive dependencies. Or, where was it? Someone had this issue and it was, here it is. You have to, okay, so you just keep transitively adding stuff. Okay. Yay, now we're compiling. I'm gonna run lint one more time just to make sure I don't get a regression there. Okay, cool. Alright, so I'm gonna commit this right now. And get that pushed. And now let me go over to the test code. Alright, now to run it on some of these. Let's see. I'm gonna run it on the random generated one first. See what happens. Memory error. Read is unknown.
It's over.
Why would read be unknown? Memory error, read is unknown. At time 27500, so it's pretty late in, so it's not just a reset issue. Which is good, because I thought it might be. But, alright, let's look at Verdi. Verdi time. See why, like, that's so weird though, because it's like, it's just doing straight line code, you know? Oh, wait, but if it... so if one of the ready signals is unknown, that can happen, yeah. Like, if the ready signal going back to... Okay. That's probably what it is. So, time to look at... Like, I suspect it's the ready signal, so I'm gonna start looking back through the modules to see where it occurred. And this is the part where this thing is slow. Oh, you can't even see Verdi. I guess I can screen share. Screen share my whole screen. There we go. Let's go into, let's look in fetch first. And let's look at read. So it becomes unknown there. Now read is driven by not full. So full is becoming unknown. And also, I guess I'll pull up clock as well, real quick, just to see. Okay, it's just that many clock cycles in. Which, if I had to guess, is probably caused by decode. Instruction queue.empty. Oh, is it because I never... No, I do assign to it there. Okay. So let's see. Dispatch ready, so it's not here, it's in dispatch. Why is it in... Oh, wait. There we go. So dispatch then... Ready O is unknown.
I love
Ready
Ready.
O. Okay, so Ready O is unknown. Probably because of X propagation. We love X propagation. So instruction out dot fu type. Oh, it's because I'm not. Is it because I'm not checking valid? It's probably because I'm not checking valid. That would make sense. Instruction out dot fu type, and instruction out is just that, and it comes from right, it gets assigned there. Yeah, so instruction out equals instruction out dot valid and equals rob dot ready. Instruction out dot rob index. So ready O and rob dot ready, or not instruction in dot value. So we need ready O and rob dot ready. Yeah, so I think I just need to add a check. Okay. Let's see, do I close out of Verdi? I'm gonna say probably not. I don't know, sometimes Verdi doesn't like it when you keep it open, but that's fine. I'll deal with it. Let's see, so I want to modify dispatch and ready array and not ready O. Let's see, so ready array I gets set there from the R set ready. Yeah, because I think, like, I'm guessing here, let me double check to make sure it's not coming from something else. So ready array I, that looks fine. And then of course ready O, yeah, so I think I just need to also then say and instruction out dot valid. Yeah, I probably just really just need to do that. Hee. Alright, let's try rerunning sim. Make run VCS .tv. Although first let me, I'll do this, and then let me pull up another EWS one, just so I can commit, assuming that, oh, I forgot to, well, it does compile, so that was the main thing I wanted to check. think it's getting
That's not
stuck.
good.
I think it's getting stuck somewhere. It's not printing out that it's completing any. Yeah, it's probably getting. It's probably deadlocking, which. Woo! Even more fun. Let's see. So how do you reload? Reload design. Okay. Yeah, so it's deadlocking. Or is it? Wait, is it deadlocking? Here, let me look at. Oh, we never connected up RVFI. Duh. So it's just.
Oh, oops.
Whoops. Let's quick do that. Alright, so let's see. / hvl / common / rvfi reference json. Alright, now comes the fun part where we connect all this up. So let me vsplit HCl CP, no. vsplit HCl CPU.sv so I can see where or wait, okay, wait, so what do you, hold on, let me pull up the one for MP pipeline, because I forget exactly what the format is. So it's dot, okay. And then, okay, other question. Within our thing here, what do we call it? Hopefully dot as well. Yes, okay, good. Yeah, whoops. Okay, so this one, and then I want to check RVFI, here we go. Dot RVFI valid. Dot RVFI out. Dot order. Dot RVFI out. Dot instruction. Dot RVFI out. Dot RS1 address. I'm trying to type this in. Dot RVFI out. Dot RS2 address, because I'm pretty sure all these fields match up. Hey Raymond, can you double check that all these fields match up, like the names of them within RVFIT? Indy.
Wait.
Can you double check that RVFIT, the names of all the fields match the stuff that's in RVFI reference.json? Because right now I'm just assuming that they all match.
RVFIT, let me see here. And under types, right?
Yeah. Yeah, just make sure that like it matches up with the stuff in RVFI reference.
RVFI valid DT. Where's the RV? Okay, well, let's see here. Order inst RS1 address, RS2 address, RS1 R data, RS2 R data, RD address. Yeah, I think so far so good, yeah. Yeah, just keep going. I think it looks fine. RVFI out. What about the RVFI out from line 2? Or, I don't know. Oh, yeah, everyone. No, keep going. It's fine. That's totally fine.
Okay, I think that looks right then. Let me commit this. Yeah, that's fine. And then let me. Oh fuck! I just did the wrong command. Let's see, did it close? Okay, it did close already. I ran the wrong command. Whoops, that's okay, I'll just pull it back up.
SSH.
Yeah, like it's like...
You made your own SSH thing? That's crazy.
It's like, I did QAll on the, like, current Vim, not, like, the one inside. Whatever. Let's see, MPO, be out of order. I'm gonna want to go in here and... Or did it get rid of it? Yeah, maybe it actually got rid of it. Yeah, okay, cool. Anyway, let me run... Oh wait, I forgot to specify the program. That's okay, it'll still compile at least. Assuming I named all the ports correctly, which... If it compiles, okay, cool. So then... Okay. Valid is unknown. Oh joy.
What?
RVFI, okay, so it's RVFI, the valid signal's unknown, that's fine. Anyway, what did Sai say about the late policy? I wasn't reading the messages. Because presumably, like, I was assuming it's the same, so it's like 10% for 1 day. I forget what it is for 2 days, I don't remember.
I think like 60% or something like that. I don't know. I was like 70%.
Oh, you get 70%? Okay. Yeah, so it's 30 off. Yeah, that's what I thought it was for 2 days.
Yeah, that's fine.
Man, I love using Verdi over SSH. Not really, it's slow. It's not terrible, but it just takes a bit for it to start up. Once it's up, it's fine. Anyway, let's...
I hate hoppers.
Anyway, RBFI valid. So it goes unknown there. Let's delve into the ROB, or actually, let's press here, go to driver, committing, go to the driver, not empty.
I think you can just do like trace X, but
oh, I forget. I've never used trace X.
But that's fine.
How do you do trace X?
I'm pretty sure. Okay, how did I do it? Yeah, you like right click that, and then I think. Yeah, trace X. And it brings you into another menu. And then you can see its driver.
Hold on. I did it at the wrong time. Yeah, where's... Okay, it's over here. There. Alright, let's see. X from constant X. Driven by X from...
Dispatch. So I think you
This
just
doesn't
have to
seem all
look at
that helpful.
time.
Okay, I mean, it looks like it... Because, I mean, it's checking Rob done. Oh, committing equals not empty. Okay, I think I see what the issue might be. Yeah, because I think I'm not checking the valid bit within the entry. That's what it is. Always check the valid bit. Lol. Yeah, I think that's what it is. Alright, let me... go ahead and fix that. Yeah, I think that's the main one. Yeah. But if I had to guess, that's probably what it is. No, because it assigns Rob done there, so it honestly might, it might be something else. Hold on. Rob done. Give me back the waveform. Let me check CV valid. Okay, this is also unknown, so it goes back further. Default, no grant. CDV, input packets, I. Okay, that's annoying to check. Input packets 0 through 2. Valid. So input packets 0 to valid. And okay. Check you. You are also unknown. The annoying thing is, like, it's hard to say exactly what, because it all becomes unknown, like, at the same time. Anyway, I don't know if I'll be able to fix this and have to rerun the test. So if 5 days pass and you don't pass any of my test cases, you get no credit, which is why I'm saying something else so I can tell you what needs to be fixed. Okay. Okay. So what, we get 30% off then? 30% off of 25 out of 100 is 0.7 times 25, which is 25, 50, 75, 100, 17.5. I don't know, I don't really feel like doing the math on it right now. Say, yeah, like it's hard to exactly tell. Okay, I mean, I guess I could check. let's see. There's input packets. There's the packets from the FUs. Check that, I guess. Let me get rid of all these. Okay, so it's not that one. This one, okay, it might be the ALU. Hold on. That did not. Grang. That's okay. Where did? Okay, so it didn't take me anywhere here. That's okay. I know. So that was 0. So let me check. Checking the ALU here. Let's see. So we say. Yeah, this one keeps going unknown. Done instruction not valid. Which means the first reservation station. Let's go down to the reservation station. Wherever it is. Entries unknown. We set all of them to 0. Like we set all the valid bits to 0. And then, so when we clear it, we set the valid bit to 0. So let's see, so what do we set? If out valid, fu.instruction equals entries next out slot, otherwise it gets valid equal to 0. Is out valid unknown? Oh yeah, that looks kind of unknown. Jeez, this is slow. Oh yeah, so out valid goes unknown there. Which is caused by probably one of the entries having an unknown value. So let's check here. This instruction. Where is the unknown value? Okay, well, so let's see. If I zoom out. So the input instruction being valid is not the issue. So the issue might actually just be in the reservation station. Somehow what it's calculating here. Okay, it's saying else if all that. Out valid. Why would it be unknown? Why is this becoming unknown? Hidden instruction equals entries next out slot. So we know entries I is valid at this point. Yeah, wait, why would it? Let's see, because like out valid is becoming unknown. Hold on, let me clear the list out just so I can get a better look at what's going on here. So out valid is becoming unknown. I guess I can say trace X. see what it says. Dispatch instruction out array 0 dot rs2 ready 0. Oh, is rs2 ready 0 unknown? And then incoming instruction. Hold on. Let's see. So let me look at the incoming instruction again. So valid is fine, but what it's saying is it's coming from rs2.ready. Oh yeah, rs2. No, because, I mean, okay, so rs2 used. Oh, rs2 used is unknown. Yeah, that might be causing issues. Unless it's... No, yeah, because, I mean, it's not valid there, so there's not an issue there. Why is that happening then? Watch it be because xprop sucks. And it's being like overly cautious and like propagating an unknown when it shouldn't be. Because as far as I can tell, like this isn't, like it's not getting bad data here at all. So if not entries I.valid, else if it's not used or it's ready and not rs2 used, why is it becoming unknown here? What? Okay, wait. Yeah, so it's at this edge here. And so, or I guess, okay, I mean, it's not actually, it's when it then checks it. Used, ready. So we don't care about these signals. I just care about these here. So let's see. Like zooming out, is there any spot previously? I mean, I guess I could like look into the entries as well, which that might be worthwhile too. A little bit of a pain, but nonetheless probably worthwhile. I mean, okay, so I guess like does this have any kind of content to it here? we have out valid. There we go. Yeah, so then that becomes unknown. So, okay, that's not particularly helpful then. Yeah, I mean, I guess one thing is like it'll always take the latest one that meets the criteria, but that should be fine. Like, I don't see any issues with it. You know, but yeah, because I mean, like. Yeah, like there's nothing here that would indicate an issue. Man, why is this becoming unknown? Why is out valid unknown? Yeah, I guess I just need to look in the entries at this point. And see what's happening. Okay, there we go. So they're all valid. Is it this one? Yeah, I think it's this one here. Yeah, so it's this one. This one's becoming unknown. Yeah, it has a high used, but ready is unknown. So what I'm gonna do is one. I can get rid of these because I know it's not them. So it's coming from entries 1. Yeah, so it's coming from entries 1. As for where that comes from, It's probably, I mean, it should be coming in. So it specifically is RS2 on entries 1. I mean, presumably it's coming in on the CDB. Another potential thing is like, I don't know, maybe something down here is happening where it says like it checks against the physical register. Now let's see, so RS1, RS2. I mean, is there an issue on the CDB? Where's the issue coming from? Watch it be that there's like a really, really long combinational loop. No, there shouldn't be. Like, watch there be like a really long combinational loop from... No, because that can't be a combinational loop though. Let's see. CDB valid, CDB RD valid. Well, that goes from 1 to 0, that goes from 1 to X, so it's not... I don't know, I mean, unless it's like a previous clock cycle. Because, like, I'm pretty sure, like, I didn't see anything about... so let's see, so... Entries 1 valid just went high. Which... Yeah, that probably happened just because... like, we just got something that came in on the previous clock cycle. Like, if I check next in slot, I don't know, I guess I should just check. I can check on here. Check within U. Specifically just RS2 and valid. Get rid of everything else. So yeah, so that came in on the previous clock cycle. It's at 2DF0, which, yeah, DF0 matches there. So I'm guessing what might have happened is, so it's the issue is not here then. The issue is somewhere else. Like, the CDB RD valid is unknown, despite valid, or wait, hold on. Oh, wait. Oh, okay, I think I see the issue here. Yeah, I think it's because, like, so on the previous clock cycle, it wasn't valid. Yeah, I think I see what's happening here. Let's see, so they're saying out valid, fu.ready. So these will never overlap, but it's possible that there's an overlap here. Yeah, so I think the fix is basically, I think I just need to check if the entry is valid, which I probably should have done. It's another case of not checking the valid signal. Lol, lamau. Hee. And it's funny because so far this has all been my code that there's been bugs in. Crying. Down here, yeah. Yeah, and so like if it goes to 0 on the next clock cycle, we don't care, but... Oh, but like is this still... Let's see, so... The ROB... Let me look in the ROB. Let's see, so the ROB... No, not the ROB, dispatch. That's what I was checking. Let's see, so... Instruction out. And then we just send that to the reservation station. Marsted I dot instruction. Oh, it's because I haven't updated this, but that's okay. But yeah, so it checks against the one coming in already for us. So we don't have to check this one here. But once something's already in a slot, yeah, so I think this is what we need to do then. So we say if it's valid, and then see if it works this time. Looks like it's stuck again. Woo. Although it did at least say duck commit number 0, which means it, I don't know, I guess it at least committed one instruction now. Yay, we're committing one instruction. At least. It looks like it's probably still stuck unless it just takes that long for it to run, which I don't know, I kinda doubt. I mean, it probably got stuck. Given that the IPC is so low, what happened is it probably got deadlocked somewhere. Yeah, so we probably have another deadlock then. Yeah, see, like... Yeah, like, it got deadlocked somewhere. Alright, so I'm just gonna select all those, delete, and I can see at least how far it got. But yeah, this smells like a deadlock. Like that's why the total time is so high. Anyway, let's see. We'll go back here. Pull up the RVFI. There it is. And let's zoom in. that's it. That's all it got through. That's so few instructions. I mean, at least, okay, so it did an error, so it never actually put out like an incorrect instruction. And like, if we look at the RVFI out, and look at the order here, you know, it got pretty far before stalling. You know, it got up to this instruction here, which, yeah, so it got partway down. We got through 48 or so instructions. Yeah, or we got through 49 instructions. 49 down, 10,000 more to go within this test bench. So the question is, where is it stalling? Okay, so I guess the first thing to check would be, let's go into the ROB and see what instruction it's currently on. Let's see. Let's pull up head index. So it's currently waiting on, looks like 9. Yeah, so it's waiting on instruction 9 to finish. Let's pull up, let's see what instruction 9 is. Let's see, instruction 9. It's an ALU instruction. Interesting. Let's see, are you gonna tell me, here we go, the PC. So it's 124. I'm gonna pull up the disassembly, but let's see. Let me just, I'm gonna pull up the disassembly for this. So which one was it again? It was 124. Which is a shift right logical immediate X13. Okay, interesting. So this, well, now this is not the first one that. So it's not the first one that has had the same RD and RS1, because you can even just look up here, or yeah, I mean, like, all of the LIs at the start did that, so it's not the first time that that's happened. So what could be the issue with 124 here? SRLI. And honestly, the issue might not actually be with 124. It might be, you know, somewhere, some processor state. Yeah, let's see. So this one's waiting on some physical register. Let's take a look at. I guess I'll take a look at both of these. So first of all, RS2 is not used. I think we can safely ignore that. Let's check RS1. So it's waiting on physical index 61. And I mean, I guess I could just look at the code here. So X13 was last done in a division. Interesting. This might actually be the first time that, yeah, this. So what's special about 124 here is it's the first time that we've used the result of a division. Okay, so it's getting stuck on a division basically. So why is it? So there might be a bug in division.sv then. That's what I'm leaning towards now. Because, like, for one reason or another, division.sv is not outputting something. Let's take a look at division.sv. Which, I mean, like, you know, the divider is slow, but it shouldn't be this slow, you know? And also specifically, although I don't think this is super important, let's see, so X13 is... so it's waiting on the first division. Okay, so it's not even... Yeah, okay. So it's not even finishing the first division there. So... leaning towards... leaning towards it being an issue with the division functional unit. Because, like, the other functional units so far have been working, which means, or I don't know, has it encountered a multiply yet? Because I guess there's that too. See, 124. No. So I mean, it's possible that there's an issue with multiply too, but two separate files. The issue is probably in division, if I had to guess. I gotta mentally prepare myself to dive into that file. It's like division.sv is the one file that I have not actually looked very well into. But the issue is most likely in there, though. Let's see. Let's pull this up. So we're looking for a result on 61, like the 61st physical register. So gotta remember that. So 61, just as a make sure this is what's happening. I'm pretty sure it is, but let's see. I guess I can check this first. Actually, wait, let me pull back up. Yeah, let's see. So we're looking for 61 RD. Let's look at these. And actually, let me pull you back. And I want to look specifically at the ready signal here as well, just to see that it is How is it ready so soon? Is it... what? Let's see, so ready... What is going on here? Let's see, so here, it was 1, it was 1, so it looks like it, yeah, this is, yeah, so this is the first time that it's gotten something in here. So 61, 62. I'm surprised it's going in so fast. This file. Like, this is the one file that I like probably understand the least in the design right now. Sigh. I mean, I guess... Here, let me just look through it right now. There's so much stuff in this file. Let's see, so on reset it goes to idle. If the input instruction is valid and the queue isn't full, it goes to busy. If complete, then it goes to idle. So if it's in idle, if it's valid and the queue isn't full, it puts that into the register, and then it goes to busy. So then it waits for complete. So it stores that into the register, that into the register. So like it stores all those values that it's kind of read off there. As well as the RVFI. And then it stores those. And so then it sets start to 1 on the next clock cycle. And then in busy it sets start to 0. So for 1 clock cycle it sets start to 1. And then I guess one question I have right now is, what does it set ready to at the input? State equal to idle, and the queue is not full. So we're only ready if we're in idle, and the queue isn't full. I guess I should check, let me also check the datasheet for the sequential divide. How does this work? Let's see, so we have, so you set start to 1 for 1 clock cycle. Operation completed. Then show discussion. User defined number of clock cycles. As long as start equals 1, the division. The calculation begins, followed by valid output flagged when complete. Alright. So hold. What do we set hold to on this thing? Hold we set to hold, which is always 0. Okay. So that should be fine. Because I'm surprised it's finishing so fast is the thing. It's possible that it makes sense that it's finishing so fast, like that first division there. Because like, okay, like, I guess I can look at the states here. So, so we're in idle, and then it goes to busy. And so if I check complete and I check start, so start is high and then complete is high in the same clock cycle. After reset conditions are released, there are no restrictions on when start can be set to 1 and then to 0. Continues through the first clock cycle.
Okay, what's going on?
The divider.
No.
Yeah, there's a bug in how the divider works. I'm currently working it out. Man, this sequential divider datasheet is it's so strange. Like, why does it do this? After reset conditions are released, there are no restrictions on when start can be set to 1 and then to 0. However, if start is set to 0 immediately after reset n goes to 1, and start equals 0 continues through the first numsci clock cycles, then complete will go to 1. The first complete equals 1 when no start is initiated following reset may yield invalid results and should be disregarded.
Okay, buddy.
God. Operation completed. And because, like, in general, the complete, or the completed signal, or whatever it's called, or complete, it remains high. Because I think there currently is an issue, just in general, where let's see, so when star equals 0, the calculation begins. Oh, when configured with no input registers. The drives inputs must hold the values constant for the entire time. They are captured when start is high and ignored until start goes high again. Okay. So I think what you want to do is, okay, so start gets initialized to 0. Start can be set to 1 and to 0. However, if start is set to 1 immediately after reset n goes to 1, and start equals 0 continues through the first num set clock cycles, then complete will go to 1. The first complete equals 1 when no start is initiated. Following reset may yield invalid results and should be disregarded. Remainder, not modulus on the output remainder, which corresponds to parameter TC mode determines whether the data of inputs A, B, and outputs is unsigned or choose complex numbers. Have an asynchronous reset mode equals 0 or synchronous reset. Zero mainly after reset n goes to 1. Start equals 0. Because I mean, there was something about using asynchronous reset for the divider. I'm not entirely sure why. Like, is it to avoid this issue? On when start can be set to 1 and then to 0. Anyway, so I think the way I'm gonna rewrite this, let's see, so first I want start to be initialized at 1 first. That way it keeps it in the initial state, because it's like when it sees 0 immediately after the reset, it doesn't like that, I think. So I think we have start at 1, and I guess like while the divider is not doing anything, we'll keep start at 1. And then it's only when we want to start an operation that we actually lower it to 0, I think. Actually, hold on. because like this is annoying to deal with, but at the same time, I'm not sure if keeping start high when it's not in use is a good idea either. Because then you're like feeding data in. I mean, I guess that's not the worst thing. I don't know. Actually, it might be fine. Let's see. So then. So we'll initialize start at 1. And so then if that instruction is valid and the queue isn't full, then first we set the registers, which are the inputs, right? Like RS1S is the input, yeah. So we'll do that. We'll keep this guy at 1. And then we go to busy here, we set it to 0. And then once we see the complete signal, then we say next state idle. Where does next state get updated? Oh, right there. But yeah, so then we assign start to 1. And so then we'll transition to the busy state. And then once complete is high, then we say next state idle. And so then when does it push? So then we do result to queue, which actually, let's see, is this part right? If divide by 0, div result, negative div result. I'm pretty sure this part might actually be incorrect. Specifically, what does the spec say? The RIS5 spec for multiply, the remainder should just be the original dividend x for divide by 0. So yeah, so we set all the bits for 1, and then we want the remainder to be the full value x. So let's see, how do you handle that? Do we still have, let's see, so we say complete and state is equal to busy. Yeah, so we'll see complete there. Then we'll go back to there. We'll set state to 1. Yeah, I don't think there's an issue of like power, because the registers only get updated when it actually feeds something in, so I don't think power is actually that big of a concern there. Like, it might be, but yeah. But yeah, queue data in if it's ready, and yeah, so that's probably right. Surprised you can fit that many signals inside the queue. But anyway, so I think, so what we want to do is, we want to say if div rem reg and then we want to say, in this case, result to queue equals the original input A, which was not RS1 abs, but I guess it is RS1 abs. It's RS1 abs, but you might have to negate it. That's kind of annoying. Yeah, the logic for this is not trivial. Let's see. But yeah, cause like div sign. So that one will be 0. This one will be 1 or 0 depending on the sign. Yeah, so if it's 1, then we want to negate it back. Crying. And so that's true for both signed and unsigned. Yeah, both signed and unsigned remainder. Anyway, this might fix it. So the main changes that I made, I think, are just changing how the start signal is set. Yeah, because like it'll transition to busy, in which case it's only when it goes to busy that it like lowers the start signal, and then it stays low until it transitions back to idle. And then so let's say, so it's in idle, but then start is 0 still, at which point start will go to 1 and then back to 0 if it immediately went into a thing. Okay. I think this works. We'll see. Maybe. What's the expression for queue depth look like? Width plus log2n rob plus 1 plus 5 plus log2n physreg plus number of bits in RVFI. Lol. The funny. So then you take that out and okay. So this might fix it though, I think. Yeah, I think think this works. Yeah, I think this works then. Let's see. Wow, now we have a spike mismatch. RDW data. Okay. Let's see. Oh wow, it actually did do a divide by zero. It actually tested it for once. Let's see, what was the order? Order 74. RDW data. So it was a divide by zero. And it was supposed to output so it was supposed to output that, but it outputted that instead. Let's see, how do I fix that? This is literally what I was just writing here. So if divide by zero, if div remreg, result negative. So does it look like it, did it output? No, that's definitely not the negative of it. So something stranger happened there. So if we're in the busy state, and if we're in the busy state, it won't have like put something in, right? So RDW data. No, unless there's an issue with the queue, which I kind of doubt because we've been reusing that same queue a couple times now.
Hello, sorry. So sorry, I'm going back to what did I do wrong?
Okay, so I already fixed one of the issues, which was you didn't handle the start signal properly.
Okay.
Which that was just, I read through the data sheet for the divider, and I'm like, like you know the only changes I made, it's literally just initialize start to 1 instead of 0, and then in idle we want start to always be 1. We don't want it to be 0 while in idle. And that's the only changes I made.
Yeah.
And that seems like it fixed it, but now there's an issue of it's outputting the wrong division result, which is strange.
Then it's probably, my first guess would probably be somewhere in the, yeah.
Yeah, see, like I tried to fix, because like
Maybe
it's a divide by zero that it gave the wrong result on, which
Really?
it could be because somehow this divide by zero code is still wrong, but this should be the behavior that it has for like, or it's a remainder by zero, not a divide by zero, but
all the other divide instructions though?
well, yeah, because it got through a bunch of earlier divide instructions. I could actually check what. Let's see what.
Well, yeah. What instructions were there?
What instruction did it? So it was 128, which actually, okay, that's the one that's like right after the thing. Hold on. Then. So it was one. Or I guess. Is it a little later? Let's see, what was the one that I got stuck on before? It was like 2 back-to-back divs. Oh yeah, so it was 110 and 114 that I got, or it had issues with before.
Interesting.
That was because it just wasn't. It basically like the processor deadlocked because it just never was outputting a value, which again was caused by like incorrect start handling. But so it got through those two divisions fine.
Cool.
And then there was nothing else, and then there was a remainder here. So it's not doing the right thing for the remainder, which it's weird because it's giving a result that doesn't even look
like remotely right.
Yeah, here let me just run it again.
Yeah.
Yeah, because like it's not even like the two's complement of what it should be. It's like
What is that?
yeah, it's a completely
Can you
different
just
answer.
trace back that answer.
I could, but at the same time, like, so there's a couple different causes it could be. Which I'll probably pull up in Verdi just to see which one it is. But just thinking through, it's possible that it's somehow. Actually, okay, let me just pull up Verdi actually. Yeah, so the result, like, so it should be C2. Oh wait. Oh, I already have, or wait, no, I don't have Verdi open. Oh, it exited out of Verdi because I ran out of time.
Yep.
Hee. I'm surprised it gave an error there. I'm pretty sure it used to not. It would like just spit you out on a terminal if you didn't have like a X forwarding. But anyway, so we're looking at like C2. Like I should have been doing a division with C2. Like C2 divided by 0, or remainder by 0, not divided by 0, but let's take a look once it unfreezes. Let's take a look in here, and then I want to take a look at, so down here we set RVFI reg here, so I'll probably go based off of this. And specifically I'm looking for, let's see, which instruction am I looking for? Bin range and disassembly. Specifically looking for instruction, where is that? So there's the two divs, so it's address 128. That's the one we're looking for here. So let me pull up PCR data, and I guess I'll look at our data for RS1 and RS2 as well. Let's see. So we're looking at, oh geez, it. Oh, well, yeah, okay. Oh, that's funny. Wait, so it executed 110, then 128, then 114. And also this seems way too short, so there might actually still, it might not even be, yeah, okay, that would make sense. It's probably not actually the code there. I think it still is, there's an issue with, like, yeah, because it's starting after, like, it should not be this fast. Well, I guess it could be, because it's doing a divide by 0. So let's look at the complete signal. As well. So we have complete. Okay, why is it still doing that? Hold on. Or wait, did I... No, I did reload it, yeah. So why is it still doing this? We say start one. Let me look at the states as well. So we're in idle. Or so we get that. Then we go to busy. Okay. So I think I see the issue here. So it.
What did I do?
God, the control signals for this divider are not trivial. They are strange. So the thing I did to fix it did not actually fix it. So let's see. I might honestly, it might be worthwhile to just like add another state or two to the state machine here, just to like really ensure that it does the right thing.
Sure.
I might do that, but let me think through. Okay, so what's happening here is, you know, it was in busy, it finished doing the thing, and it even committed it correctly. And then, you know, because like the first division committed correctly. It's kind of interesting because it's actually doing a division here. Like, okay, so the order here that it's doing these in is out of order. Look, it's doing the division at address 110. Then it's doing the remainder at address 128, then the division at address 114. Like that's the order that it's doing it in the division function unit. So it's first, like it's doing this one here, then it's going down here, then back up here. Ah, that's so cool. Out of order processor, so cool. It's jumping around all over the place. Anyway, so the issue though is, so it goes to idle, and then it goes to busy. So what is the state at the start here? Okay, so initially we have start is 1, complete is 0. And then it does that, it starts running, we get a complete signal here. So this complete signal will remain high. Yeah, honestly, I might just want to stick in an extra thing.
That's fine.
Or let's see, because we do that. We have start high for a cycle there, and then we do busy. Or I mean, like, I guess the alternative is actually maybe doing like combinational logic for start. That might also fix it. So we want to say start is high if we're in idle, and then in busy we bring start low. Well, no, because I mean we don't quite have the values. Yeah, so I think the solution is probably just to add another state. Like maybe call it begin or something. Yeah, I might just call it that. Or idle, start, busy, maybe. Yeah, I might do that. Let's see. Let's see, so where is it here? Idle, start, busy. So we were initially then we transition to start. If we're in start, next state equals busy. And then down here, start. I think we also just want to say start get 0. Yeah. Let's see, so we're there. And then yeah. So first we go there. But yeah, so like first we set these registers, which might not actually be necessary, because I mean the divider already has registers internally, but whatever. I don't really care if it takes an extra clock cycle to complete division. It's already a long operation as is. It's just like whatever. But yeah, so first it'll set those. Then clock cycle later, start goes to 0. And then after start goes to 0, that's when it starts checking for the complete signal. And so then once that goes high, start will still be 0, but it'll go back to idle. And then in idle, so then when it's in idle, it will so start is still 0, but then it'll go high for 1. Yeah, because like the sequential divider, it latches its signals, like it essentially has a flip-flop at the input, and that flip-flop's enable signal is just connected up to the start signal. That's at least kind of one way to think of it. And so here we set these values. At the same time we set start 1, and then we set start 0 to make it start. Okay, so I think this works. Let's try it. And now it's back to hanging.
Yeah.
Back to a deadlock. Joy. Man, at least the ones where it's like a mismatch, like it's not as annoying.
Right.
But when it's a deadlock, very annoying. Yeah, that definitely, like whenever the IPC is that low, it's a deadlock.
Yeah.
Joy, yay. Alright, so for deadlocks, I think the general strategy for deadlocks is basically start in the ROB, and basically check to see like what instruction it's waiting on. So it looks like we're waiting on B right now, for instance. Yeah, so like you first check what are you waiting on here.
7.
and then you pull up that entry within the ROB, and you see like what instruction is it. Right, so it was B. Yeah. Yeah, so it got stuck waiting on B. And B is 11. Yes. So it's currently waiting on this one here. I'm not sure what it just did. There we go. Okay, so good. That one's valid. It's an ALU op again. Haha, figures. But typically, okay, so typically it's not actually the ALU op that's the issue. It's whichever one it's waiting on. So let's take a look at what is it waiting on. Or, well, first off, let's just take a look at what's the PC for this instruction it's getting caught on. The PC is 12C. So it's trying to do 12C, but it can't. So let's take a look at the disassembly. Make sure I got that right. A12C, yeah. So it's getting stuck on A12C, which is an SRLI on hex 26. That SRLI came from an XOR all the way back there, instruction 100. It's an XOR though, that's interesting. So it's not a multiply, it's not a divide that it's getting caught on. It's an XOR. Why is that XOR not completing then? Peculiar. Peculiar. Very, very peculiar. Why is it getting stuck on that XOR? Waiting for it to complete. I mean, I guess I should go back, I should actually go back and check the reservation station and make sure that this actually is what it's waiting on.
Yeah.
Because it's like, okay, well, let's go look at the reservation station for the LU. Yay. So I guess some information I should probably check while I'm here. I should check these. Let me double check. So the PC it's getting stuck on is 12C. Right, because the head index, which is what it tries to commit, right? Yeah. Was B, which is 11. Okay, just double checking I did the math right on that.
Okay.
So let's take a look inside these. So first of all, that's used, which is good. This one's not used, which is correct, so I just wanted to double check that. So the physical index is 5D. Alright, I'm actually going to pull up a scratch pad here, just so I can write this down. So the instruction was... Let's see, so... RS1 was 1A. Which 16 plus 10, 26. Yeah, so 1A. Yeah, so it was 12C here. So instruction at 12C doesn't commit. Depends on instruction 100, phys reg, what was the physical register? 5D. So it depends on phys reg 5D, completing, yeah. So that's 100, yeah. Which actually, that one's kind of strange to think about, because we've already committed instruction 100 by virtue of, well, we got all the way to 12C and we hung there.
Yeah.
So I think the deadlock probably doesn't actually have much to do with it. Or, yeah, because we got all the way to there and then we hung. What's the issue here then? Because this happened before, right? Like, because it was like the division instruction that's up here, like that hex 13, it's then used in the SRLI. So it still committed the divide, but yeah, so this might still just be another case of like there still is an issue somewhere. Like it's a case of potentially a missing forwarding path or something, is my guess. Like somehow it still just isn't getting that it's ready, because like it was able to commit the XOR there, right? So like the result should be ready because we committed it.
Yeah.
You know, here, let's see. So we got our hex 12C. Wait, did I do the calculation right? So hex 26. Yeah, because the result of the XOR is hex 26. Yeah. And no other instruction writes to hex 26. Yeah, so it should be that. So we committed hex 20, or like we committed the XOR, which means it had to have gone on the CDB in order for like ROB done to get set to true. And so when that happened, it didn't properly update something. So I guess what might it not be properly updating? Like it's always difficult to tell, like, you know, where is the deadlock happening?
Right.
Because it's like, you know, at some point the CDB had this instruction on it, the XOR there, like 100. So I guess I could look for that first. If I just go back out and just take a look at the CDB. And let's just see, like, you know, when, and this is why it's nice to have the RVFI here as well, because I can just look back through. Let's see, so I'm looking for, this is going to be a pain to look for. Like when was PCR data 100 basically. I'm gonna guess it's probably closer to the end than the start. But yeah, so like when was this thing when was this 100? See, not there. This might actually be a fair way back. Let's see. So there's 114, 174, 180, 130. Very out of order. 17C. I don't think it's in that bundle. Let's see. What were you? 178. 158. 28. 64. 68. 60. Alright, so I mean, it might be actually further back. Let's see, 140, 110, 148, 24, 50, 120. There it is, 100. Ah. Interesting that it's held valid for more than a clock cycle. That's kind of strange. That's a little unusual. Why would the same instruction be held valid on the CDB for more than one clock cycle? Because theoretically it shouldn't be.
Probably ALU.
No, it might be the... No, I mean, it's not going to be the ALU. It's going to be either the reservation station or potentially something earlier, or... Yeah, so I think maybe I'll try working on that first. I have an inkling for where it might be. And that inkling is specifically the CDB arbiter. Because probably the changes that I made, maybe I forgot to let's see, input packets. Let's see, so if that one's how did I make this work? Watch me have like implemented this incorrectly, like the additional data buffer that's at the start of the CDB arbiter. It's entirely possible that I didn't do this right. Actually, yeah, why is this being held? Unless, I mean, it's possible that the instruction is getting duplicated as well at some point, which is also possible. Like, it might actually not be an issue with the arbiter. It's possible that it's just, like, duplicating the instruction. Which itself is not a terrible thing, but it could cause issues later, so it's good to fix any, like, instruction duplication glitch. Our CPU has cheats enabled. It's duplicating instructions. Anyway, so this one's the right one though, right? PCR data 100. Yeah, like it's holding the same value here. Anyway, so the phys reg is 5D. 1A and 5D, which yeah, that matches that here. So yeah, so why is this being held for so long? Like it's being held for, what is that, 3 clock cycles? There's some kind of issue somewhere. Let's see, is that, okay, so is the issue in the arbiter? I'm gonna guess it probably isn't, but it could be. Let's see, so we say if the ready signal going back, that's when we update it. Or input packets I. What might be the issue? Yeah, because like essentially it computes that out, sets input ready I. So then once, like that one will go high, which then causes it to pull in another. Yes, I don't think the issue is in here. I could double check in the arbiter, so I'm gonna want to zoom in. Maybe not quite that far. But like this is the time step that we care about here, at least to some extent. Like this instruction here. So I might want to clear this out a little bit then. Anyway, let me go to the arbiter. And so I want to take a look. Like I want to see, like, is it actually pulling 3 instructions in? Oh, okay. Okay, so this is just 1 the whole time here. Interesting. Okay, so that's not super interesting there. So now what I want to look at is the packets, because it is like, it's basically constantly trying to pull packets. So specifically I want to look at This one. Yeah, so we have that it's valid. Yeah, so it is sending through like there's 3 instructions coming in here. Because like ready is high throughout the whole thing here, and then we have valid high. So it is sending this through, which makes it even stranger because it's like it's sending this instruction out on the CDB 3 times. How is it, how is it not getting across? But I don't know. So this comes back from the ALU. I'll take a look at the ALU. I doubt the issue is in here, but because we do just like we basically forward everything through, which is why I'm like really doubtful that the issue is in here. It's possible that the issue is in the reservation station, but I also kind of doubt that it's in there too. Is it? No, because there's no ready signals for the free list or the RAT. It's only the ROV that has a ready signal. So it's not there. And I know I do check the ready signal for the ROV. So why is it duplicating it 3 times? Let's look at the reservation station. But yeah, because I mean, like, this might not be the actual issue. Because, like, the issue is that, like, that instruction, like, 12C or whatever, is not getting the ready bit set to 1, even though this thing does go out on the CDV. And so the issue is that, however, there should not be, like, 3 copies of the same instruction going out here. So there's an issue somewhere else, and the question is where. So let's see. But yeah, because like if fu.ready, we set the next out slot dot valid to 0. I don't know, do I want to check if there's 3 entries for the same instruction? Maybe, but So it's getting 3, 2, 3. So that tells me it actually, like, it's filling in different entries, which means, okay, so I should just check the input then, because it looks like it is, like, it's probably not an issue in the reservation station. Like, somehow the instruction's getting duplicated. Watch the problem be all the way back in issue or something. Like, it somehow is getting duplicated all the way back there. That would be funny. But yeah. Anyway, so let me take a look at dispatch, like the stuff coming in here, because we have dispatch.instruction. So dispatch.ready, yeah, it's set when we fill stuff in. Okay, so let me take a look at Hue, which once again it's a pain looking through this thing. Looks like there are 3 instructions here though. Let me also pull up dispatch.ready. It's high the whole time. And valid is high through the whole thing here. And these are all that same instruction. Yeah, 100. So is the Rob index the same for all of them as well? Because that would tell me actually a lot of info. It is the same Rob index. Okay. So the Rob index is the same between the 3 of them. So it's not getting 3 different Rob entries, which that tells me something. Namely, it's probably an issue in decode. Or not decode, dispatch. So let me pull up the code for dispatch. What did I change here? I'm not sure what I changed. What did I change? I do not know. Actually, yeah, what did I change in this file? It's complaining that I changed something, but I don't know what. If only there was a way to have them tell me what I changed. I mean, I guess what I could do is, I could say, vsplit terminal. Why did it open it like that? I'm not sure why it did, but see, like, okay, so did I change the arbiter at all? No, but I did change the swap file. So what I can do is write the arbiter, run this again, and then check if to see what changed. I commented that out. That's it. Okay. Well, that's fine. Because we don't actually need that signal anymore because we're not doing the round robin scheduler. Okay. So now let's check dispatch. So we say instruction out.valid and equals rob.ready. Rob instruction.ready or .valid and equals ready out. Ready out and rob.ready. Okay, let me think through how this should work. So we say So instruction in, yeah, that's at the input there. So we move, if we have ready out and rob.ready, and then we and the other one's thing there, and equals rob.ready. See, like the fact that the rob index is the same between the 3 copies of the instruction tells me like it's not allocating different rob entries. So the issue should be somewhere within dispatch. Unless it isn't. I mean, it's possible that it's also in the rob, so I guess I should check that. Let's see. The rob, yeah, we set that, so only if we're not full, and then we increment the tail pointer. Yeah, so like I don't think there's an issue there. I mean, do we send back a ready signal? And if so, what? Rob dispatch. So what do we set dispatch? So we just say dispatch.ready equals not full. Okay. Anyway, let me pull up dispatch in here. Pull you up. Let's see, so we have this instruction in here. Let's see, so I'm gonna look at you, the rob index, valid as well. So we have these 3 instructions here. For these, so for the first 2, move is 0. And the reason for that is so rob, so that one's always high. That one's high. Wait, what? Wait, so move is low for 2, then it goes high. But this is it not calculating move right? Or is move getting set somewhere else? No? What the fuck? Oh wait, is it in the dispatch? Oh, it might be in the dispatch? Or ready O. Instruction out. Ready O equals 1. Oh, I guess, okay, I think it's because ready O gets set all the way down here. So it starts off at 0. And then equals instruction out. Wait. How does this get set? Ready O. I don't know, like the issue might go away if I just move this ready O calculation up. A conundrum. So this is the ROS. Let me look over here. So radio intuitively is supposed to represent right, so it represents if we have some output that's ready. Yes. And then and not radio and instruction out dot valid. Let's see, because I mean, effectively, like the pipeline primitive that this is implementing here is, I mean, really, it's two pipeline primitives sequenced one after the other. The first one is where it splits off to the ROB. That one's kind of like a duplicating sort of split, where, you know, takes in a packet and then it sends that packet out along both directions. Whereas the second kind of split it does here, where it splits it out into the individual reservation stations, the packet only goes to one of the reservation stations. So it's kind of like a filtering split or whatever. I don't know. And so the way the logic for those works is, because like the logic up here is correct for the kind of duplicating split. Like, I mean, I'm guessing the big issue is that, like, I'm setting ready O down here when ready O should be set all the way up here. Because, like, I'm using ready O before it's defined, basically. Which, that's probably part of where the issue is coming from. But, yeah. Yeah, and like I almost wonder, like, see, I'm trying to piece through, like, is there circular logic here? Like, is it just the way that I ordered things within this always comb block, or is there actually circular logic at play here? Therefore, you know, there's some issue in the design where I'll have to, like, I don't think there's circular logic. There shouldn't be. Because, like, at least what I remember about those two pipeline primitives, I don't think doing two splits, one after the other, would cause, like, circular logic, yeah. So, but no, like, the issue, at least, the thing that's causing the duplicated instructions is right here. Like, as indicated by, like, the ROB being the same, like, the ROB index is the same between the three. Like, if the issue wasn't here, the ROB index would be different for each of the duplicated instructions. So that's kind of how I know it's here. And, like, intuitively, there's, like, I'm using a value before it was set, so that definitely causes issues. But the question is, let's see, how do I work around those issues?
Oh. The fucking
Okay, I think this is the right order to update these signals in.
Mm.
And I don't think there's any dependence on the like in the order now.
Yeah.
Let's see, cause like so we get instruction in rob.ready, and rob.ready does not combinationally depend on. Cause I think rob.ready is just is the rob not full? Like I'm pretty sure that's what it's set to. So that doesn't combinationally depend on anything. And then we set that. We set instruction out for the forwarding. Then here we do ready O there, ready array, instruction out. And we then set move there based on ready O and rob.ready. Instruction plus instruction in. Okay, so I think this looks correct to me. Yeah, I think this looks correct to me. Let's try running sim again, yay! Assuming I didn't mess something up, which hopefully I didn't. It's still getting stuck. Yay! I love how you can like keep track of how many hours you've been working at it by how many times Verdi gets closed on you.
Oh, don't get me started.
Lol. Oh, and I also have to keep in mind because
Oh,
like in
get
2
me-
hours EWS is gonna restart too.
Oh, don't get me
Oh
started.
joy. Joy
Don't
is
get me started. See, I was gonna check like at what time step did it or did 100 pass through? I mean, at least now I'll be able to look at like let's see if I go in here and look at the CDB, is it still duplicating stuff? Because at least that'll tell me if I fixed that issue, which hopefully I did. We'll see. Okay, so I think, yeah, okay, so I think I fixed that issue. Because, like, looking at the order here, it changes every clock cycle while valid is high. So, yeah, so I think I fixed that issue, which is good. So now there's another issue somewhere. Namely, it's probably getting stuck on potentially even something else. Looks like it got through at least some number of instructions. Let's see.
And it's so funny. It's like you can tell when it deadlocks because the ROB fills up. Like that's how you know it deadlocks. Because like otherwise, if you think about it, like the ROB on average has the same like the same rate that instructions get pushed to it and instructions that get popped from it, because it's both like around 1-ish sort of, you know, like it, but like it's roughly the same kind of. I mean, it depends on the instructions, but you know, like our ALU, like everything is able to handle a throughput of 1 except for the divider. And so it doesn't fill up under normal operation, again, except if you have like a bunch of divisions and whatnot. Then maybe it does, but anyway, so let's see. So it's getting stuck on B again, which is 11. So let's look at the entries. So it's getting stuck on 12C still, which is still that SRLI on hex 26, which comes from that XOR at 100. Okay. So the question is, why is it not indicating it there? I guess maybe one thing, because one place I haven't checked is like the RAT maybe. So if I check the RAT, like why are the ready bits in that order? Whatever. Because like, okay, so like, so the physical register, okay, so I'm just double checking. The PC, yeah, is 12C. And so let me just double check that the physical register that was allocated, yeah, it still is 5D. So it's waiting on 5D, and presumably it maybe never comes or it never gets updated. Something like that. And so, and like the architectural index is 1A as well. Which 1A is equal to 16 plus 10, which is 26, yeah, which is what's written in the code. And so, yeah, like what I want to do is I want to look in the RAT at, well, let's see, so I'll look in the RAT. Let's split it open, pull up 26. So 32, and then log 2 and physreg. Okay.
Wait, why is this never equal to... Oh, here it is. So it's set to 5D here. Okay, so this instruction... So this instruction comes into play right here. So that's when it first gets issued, is here. 5D is back here. Which, if I check the ready bits, specifically ready bit 26, what does ready bit 26 do around here? It instantly goes high. What? 5D. Or not instantly, like it takes a couple clock cycles. I guess that would make sense. So maybe, okay, maybe there's an issue in here somewhere. Oh, I see. I see what the issue is. It's in the rat. It's not your fault. It's partly my fault, because the advice I gave you was slightly misleading. Because like basically what's happening, right? What's special about instruction 12C right here is RD and RS1 are the same, okay? Yeah, that's important. That's part of why this issue happens, okay? So that's important. Keep that in mind. RD and RS1 are the same. What happens is the input for RS1, it's ready. It was ready a long time ago. The ready bit is set to 1 within the rat. You know, all is okay. And so what happens is, because RD and RS1 are the same, ready bit next is 0, because it just checks, you know, like the right port, and it says, oh, okay, so for this one it should be 0, because, yeah. And so, you know, it clears the ready bit, but the ready bit that it should be returning on the read port should still be 1. It shouldn't be like the new thing. Like, and this I guess is what I mean by yeah, so like effectively the ordering is you should do the CDB update, then the read, then the write. I think that's the correct order. Like basically, you know, you check against the ready bit, or you know, you check against the CDB, and then the result of that check is the ready bit that you return to the read port, and then you do the update for the write, which clears the ready bit. So you have to do it in that order. So let me try rewriting this. Yeah, like I'm pretty sure that's the correct order. Let me take a look. But yeah, that's our issue. That's where it's getting tripped up. And so then because it reads, yeah, because the ready bit was like, because it incorrectly got cleared within the instruction, then the instruction just gets stuck waiting for a CDB that happened before the instruction even existed.
like the CDB packet happened a long time ago. It's just, yeah. Okay. Anyway, so what we want to do, so we have ready bits next. I guess I might actually just duplicate this. Ready bits read. And so then what we want to do is, oh, not that. Hello? Can you not? Oh, okay. I guess it's because there's spaces on all these lines. That's okay. So then what I want to do is put this down here. Okay, there's the question of where does the X0 update need to occur. But anyway, so then the idea is we say ready bits read equals ready bits next, and then we use ready bits read down here for the ports.
Makes sense.
That way it actually does correctly do the bypass here.
Yeah.
And then the question is, where does the update to 0 occur? Let's see. I mean, actually, oh yeah, this should be fine, I think, actually. Because here, we only ever set the ready bit to 1, like this statement here. And besides, like, for the case of the architectural register being 0, yeah, so then this will always still return 1. And it's just down here, like, if we do a write, you know, it sets it to 0. I'm pretty sure the statement actually isn't even necessary, but because of all the other checks for the architectural register being 0. And then yeah, so I think this should fix it though, because now it's using it before the write, because we need the read to happen before the write, but it needs to happen after the CDB. And so let me think through, like, is there an interaction on the CDB and write? I don't think so, because I don't think they ever, like, point to the same register. Because again, like, a write happens when we just allocated that physical register, so it's not going to be on the CDB. So I think this should be fine. Yeah, you can never get an interaction. Yeah. No. Yeah, no, I think it should be fine. So we do the write port. So we set the CDB. We set that bit to 1 there first.
Oh, hello.
Oh, hello.
Hey guys.
We're getting through it.
Just checking in. What's happening?
Debugging's going decently well. It's just sometimes tracing stuff through is a little bit tricky, but I've managed to solve like 2 deadlocks now, and so I think I'm doing pretty good.
Yeah.
Hey.
Because like deadlocks are always the trickiest one, because it's like there's no indication of what might be happening where it went wrong, so it's always just like.
I'm not gonna lie,
Yeah.
I watched the one for like a couple of hours, and I wouldn't have caught that in a million years.
Yeah.
Okay, just checking. Let me know if you guys need help. This is CP2, right?
Yeah.
Yeah.
Okay, the deadline for the last Wait, tomorrow's Wednesday, so Monday night was deadline. Tuesday, so tomorrow is 70%, I believe. Is that the aim?
I mean, the aim is to get this working tonight, and I will stay up until it is, because I don't think there shouldn't be too many bugs.
No.
So it's mainly just going through. Like, I already have a randomized test bench, like just some
We're just
random
using
assembly
that.
generator. So I'm just using that, and so it's just a matter of like. And I also have a targeted one for the edge cases for multiply, but.
Alright, that's good.
Yeah, because like the randomized one, like it's unlikely that it'll hit an edge case just because like the edge cases are a register has to be all zeros sort of thing, like for divide by zero. But
Yeah.
yeah, so that's part of why I created a separate one for it. But yeah, and so we've just been working through and running this like and seeing what each issue is as it occurs.
Honestly, I've just been watching. This was just too good. It's crazy. You're
Okay.
so good.
I love debugging.
Okay. Good luck, guys. I'm sleep for 2
Hopefully
hours.
the
Feel free to ping me
NVIDIA
after.
interview went well.
What's up?
Hopefully the NVIDIA interview went well.
Oh yeah, I think it went well. I don't really care about it. I already have a thing from Apple for CPU design, so this is mostly just like
What the heck?
whatever.
Nice,
Yeah,
nice.
congrats.
It's fine. Yeah. Anyways, I'm gonna do my 2 hours of allocated sleep. Feel free to ping me after 2 hours if you need help. Otherwise, yeah. Good luck.
Okay.
Bye.
The allocated hours of sleep.
Allocated 2 hours of sleep.
Uh-huh.
Yippee.
Yippee. I love my allocated ECE 2 hours of sleep. It makes me feel real good at the end. Oh, I'm so ready. I'm so ready for recording the last chapter of EC 374. The NP versus NP is like, that's like one of my most favorite sections.
Yeah.
Sorry, anyways.
Alright, we got another deadlock.
No.
Or it could be the same one. Maybe this fix didn't actually fix it.
Make
That's entirely
clean.
possible.
Make
But
clean, make clean.
oh, the head index is different. It's F now. So it did something. It got stuck on a different entry in the ROB, so let's take a look. What's going on here? Let's see, so we're stuck on F. F is 15. Pull up entry 15. Same old, same old. Looking here. PC 63C. We're getting further. It's kind of insane how it's just like you get through a certain number of instructions and then it's another issue. Like we've gotten basically all the way down here now. Like this is like a solid. We've gotten like several hundreds of instructions in. Actually, we could even check what the order is.
I was looking for a second. Did the at least message for like the committed instructions work? What I'm trying to say is like the one where it's like it's starting to pop up with like the DUT and then it's actually showing like, oh, we're at instruction here or order here.
Well, so it's deadlocking, but it's managed to commit like several hundreds of instructions before deadlocking.
Let's go.
But it's not a mismatch though. It's just a deadlock that it's now stuck on.
That's pretty good.
We love debugging deadlocks. Let's see what this one is. So it's a REM-U.
No.
It's a REM-U that was, so it's waiting on the REM-U here. Let's see. Potentially, it could also be. So let's see. I gotta take notes on this. So we're hung on 6.3c. So this one. So we're done with that one now. So let's see. Hung on 6.3c commit. So it could potentially be hex 27 or hex 1. Hex 1 is an SLL up here. Hex 27 comes from pretty far back. So I doubt the issue is there. This SRAI all the way up here. So I doubt it's that. Because like the thing is, like, all these instructions already committed for the head index to be where it is. So like that one committed. Let's see, where was it? 6.3c. The hex 1, so 6.14 there, that one also committed. And so like the issue, because like presumably it was able to read those values in, or I don't know. I guess we gotta go take a look at the divider, see what's happening with it. Because like it could either be an issue with the divider. Like basically like the two different cases that it could be, right, is either the divider is hanging for whatever reason, or like, you know, it's not actually, you know, doing write back on this instruction, so it was never put on the CDB, or the divider's okay and instead the instruction is stuck in the reservation station because for one reason or another it didn't get forwarded the value correctly off of the CDB. So yeah, I'm actually gonna look, let's see, the late policy for this class, just because I forget what it is, if it's like over, no, it's not there, it is here. 2 days late, 30% penalty. Okay.
My grade.
My grade.
That's.
We'll live.
No, don't worry about it.
Yeah. Yeah, I really regret using interface. Like, we should have not used interface. I mean, that's not the issue here. Like, I've already fixed all the issues with interfaces, but it required a lot of, like, kind of patching code. Because, like, the system, like, the support within the tools for interfaces is kind of spotty, especially, like, arrays of interfaces. Whereas, you know, if you think about, like, arrays of structs, those always work. Like, those are perfect. You can do multi-dimensional arrays of structs. So it probably would have been better to, instead of use an interface, basically use like 2 structs, one for each direction. And like that might have actually made more sense to do compared to using interfaces. But I don't know, if I really wanted to, I could go back through and change it, but the code already works and I know what the fix is for the cases where like it throws a fit. So like the fix is basically you have to use like a generate block and then basically copy in or copy out of the array of interfaces into just like a separate like array of logic or structs or whatever. Like you basically have to use generate blocks to copy stuff in and out. You can't just directly use interface arrays within like an always com block. And the reason for that is the index has to be an elaboration constant for whatever reason, which is annoying, but whatever. Understandable. But anyway. But yeah, so let's figure out what's the issue with this instruction. Yay!
Let's go!
Because I mean, like, okay, so in terms of like defining features, let's see, is there any defining features to take note of? So the instruction in question was 63C, which is this remu here. So all of these are different. Hex 1 came from up here. These are all different. And then let's see, so hex, here I'll actually take note. So RS2 came from, or came on Arch, what was it? So it's 63C. So RS1 or RS2 came on X1 from 614, and then RS1 came on Arch 27 from, let's see, where was 620 or 27? '27 came on this SRAI, I think, so 568. I think that's right. And again, well, so like these ones probably already committed, so I doubt the issue is the one that's all the way up there. It could be, but it's like, it's a long time ago. It probably was just in the RAT. The ready bit was most likely set to 1, so I don't think there's an issue there. So why is it getting hung here? I mean, I'm guessing, I should probably look at the divider first. Let's take a look at the divider, see what's happening there. So we're looking for a PC of 63C. That's what we're looking for. Oh, and I can also check, while I'm here, I can check what physical registers it was assigned to for these. Let's see, so RS1 was 1B, which 16 plus 11, yeah, that's 27. So that physical was 29. And then this one, $4B. Okay.
So this one came in on 4B. Ready is low on RS2. What about RS1? Ready is high on RS1, which that makes sense. And that's at the time of so that tells me the issue is probably on RS2 then. Because RS1 was ready, but RS2 wasn't at the time of, I don't know, whenever it was written to the ROB, which I guess is after decode. I forget if it's before or after the forwarding path in dispatch. I guess I could check. Let's see, dispatch. The ROB gets instruction in, which is before the forwarding path. So this one came in before the forwarding path, or at the very least, like, it was never that. So the question is 614 already done at the time of commit? I mean, it was able to successfully commit it, you know. So then the question is it correctly there? And I mean, again, okay, so that was just taking notes. I was gonna check the divider. Let's see. So this one was ready before dispatch forward path. This one was not ready before dispatch forward path. So yeah, so the issue is probably, it could be RS2, you know, it could be that it's not good, or it could be the divider again. Like, it's possible that the divider got stuck. So let's look in the divider and try to find that instruction. Let's take a look at RVFI red, and see if I can find it, you know, somewhere back here. So we're looking, oh, I probably should have written down the order as well. I forget which one's easier to read. The order field is probably the easier field to read. I probably should have written it down, but that's okay. I guess, okay, this isn't terrible to check. Let's see, so let's look for the one here. So it's 63C. It's PCR data, 63C. I'm not seeing it anywhere actually in here, which kind of tells me that the reservation station maybe is never, so it actually might not be an issue with the divider then.
Oh, yeah.
Because I'm not seeing 63C at all within the RVFI data here. Like, we got 693, 630, 618, 68C, 660, 650, 20, 5EC, 5EC, 5A4, 5A0, 40, 4E3, 4D4, yeah, they're all 400 at this point. Yeah, so I don't think the issue is back here, or like it looks like it's never even making its way into the divider. So, having ruled that out, let's go take a look.
So there's two things I want to look for. I want to look for when does this go on the CDB. This RS2 here. So when does this happen on the CDB? And where is this instruction when this happens? Because that'll kind of pinpoint down like why is it not getting its ready bit set. Because it's not the RET. The issue is most likely not the RET. The issue is somewhere else, potentially. Well, we'll see. But, so let's go look in the CDB. Finding it in the CDB is going to be a pain once again, but it's fine. So let's see. So I'm looking for instruction 614 on the CDB. Alright, so then let's take a look here. So you are 6A4, so I'm looking for 614. I don't know, is there a way to jump to when? Let's see. Is there a way to find? Go to, no. Find? No. Like I want to find when is it equal to a given value? Okay, this is fast enough actually, I'll just do this. So 614.
Okay.
Oh, there it is. So there's 614 on the CDB. So it's at this time step here. Let's see, is there some indication of where... so it's at 17365. Went on CDB at 17365. Nanoseconds probably. Yeah, nanoseconds. So 17365. So this is when it appeared on the CDB. So wherever the instruction was, it didn't catch this. So the question is, where was that divide instruction at this moment in time? So I guess first I can check the div rstat. Or I guess, okay, so I probably shouldn't check here. What I should check is in the ROB, when did it get its entry for that one? So 17365, I wrote that down. And so it was, okay, I didn't write down which entry it was. Let's see which, it was F. So entry 15, when did you get your value? So 17365. Looks like it got its value there. I'll double check, but I'll expand this out. 63C. Yeah, 63C. So looks like this one got its value here. Which, okay, so it was allocated in the ROB actually pretty late, fairly late on compared to when this went on the CDB. So that tells me it I don't know, is it still an RAT issue? Like maybe? I mean, is the divider correctly setting the fields of the CDB? Because that could cause an issue too. Let me check that. RDR Tredge from Q. RDR Tredge from Q, which is the fourth field listed there. RDR Tredge Reg. RDR Tredge Reg comes from that. Yeah, so it is setting that. Yeah, because like this is a fairly long number of clock cycles later. Like for it to go out on the CDB, because like it went on the CDB back here, and this went through dispatch over here, which means that, I mean, it's possible. Like I guess I should actually look then. Like when did this instruction but yeah, like when did this instruction go through like fetch and dispatch? Because I mean, like it went through, or at least it left dispatch pretty late compared to that. So like I guess the question is, where did it sit then? Like where was the instruction, if it was somewhere? I guess I could check dispatch first. So one possibility is that it was like sitting in this register here. I see, I see. The issue is it's not updating the field in this register. Alright. It's an issue in dispatch. That's where the bug is. Let's see, so we want to do .hdl, because like, because you can't.
It's crazy.
What?
No, it's just like, I don't know. You're just too good. Whenever I debug code, it's just like I stare at the waveforms until something pops up. But I don't really think about like, oh, because of this, this, and this, you get to this solution. I'm like, this is.
No, yeah, because I'm like, I'm thinking
This is
like,
good.
okay, like, this thing went on the CDB all the way back here, right?
Yeah.
The instruction that is never committing, it went into the ROB here, but there's this like huge gap where like there's nothing happening in the CDB, like, and so it's possible that it was like stalling in here. And so I'm like, oh, maybe the instruction is like stuck in this register or something.
Crazy.
And so like what happens is like this forwarding logic here, it doesn't actually kind of like hold on to the update that happened like with the CDB when it needs to, basically. So the question is, how do I want to rewrite this code so it does? Because most likely that's the issue. I could like look at the waveforms and like try to prove it. I mean, I guess an easy way to prove it is basically like, let's look at this register here. Pull up like if I pull up this register, look at the PC, and look at that, it's 63C, so it's stuck in that register. Yeah, so 63C is stuck in this register. Oh, that's so rare. This is why we love randomized test benches. They'll catch rare shit like this. Because like basically what's happening is it's an instruction that's like stuck in this register right here for a while, and then the CDB happens for one of its operands, but it doesn't catch it. Because it's stuck in the register and there's no code in here to update the register based on like if there's a CDB, like if something on the CDB happens. This honestly, this feels similar to the, like one of the things I had to do with MP pipeline was I had to essentially like latch the forwarding path signals so that way I wouldn't lose them. It kind of reminds me of that. Like basically I'm having to like update the ready bits here within the instruction in register. Fun. Yeah, so now I need to figure out how I'm gonna rework that code to handle that. Because we have the forwarding logic here, but we also need forwarding logic on this, and I might be able to combine the two. The question is how, though. So we have instruction out. I guess what I could probably do, let's see, so if I do that, and then I could say like else instruction in gets instruction forward. And so then what I want to do is move this down here. And then I want to copy that. This way it'll actually update those bits, but I don't want it to like update this here yet. But yeah, and so I think that should work though. Because then, let's see, so when it's not moving, it still updates that if there's like a CDB update that comes through. Okay. Yeah, I think that should work. Yeah. Yeah, that should be instruction forward. Alright, let's run it again. Ah, an RVFI. On remainder.
not. What is that? Remainder. Negative remainder.
Oh yeah, those are negatives of each other, aren't they? Yeah.
My code sucks. Oh.
Lol. Let's see, so why would this happen? So it's negating it when it shouldn't. So if we think through
let's just look into my negation code then.
So the issue is we're dividing. So your code thinks that, because like, okay, so we have two operands, right? We have a negative operand for RS1 and a negative operand for RS2, and Spike is saying that the result is negative.
Okay,
which is weird. Why does Spike say that the result is negative then?
Okay, so
oh wait, it's because it's a remainder. Ah.
A negative
okay,
remainder.
Okay. Let me go. I'm just gonna look at your code because I think I have an idea for what the issue is.
Negative remainder? Oh no, okay, no, I know exactly what's the problem. But like a negative remainder? Okay.
Yeah, because I'm pretty sure. So for the remainders,
when does it become negative? Oh my god.
So the spec says, what does the spec say for negative? Let's see. So provide the remainder of the corresponding for rem. The sign of a non-zero result equals the sign of the dividend. Okay, yeah. So it's not based on the sign of the divide operation. It's based on the sign
of the dividend. Okay, so then that's not as bad for that.
Yeah, it's basically just coming down here.
And then fixing the logic there.
Honestly, what I might do, I might just kind of rework this, because it's complex enough here. Like the behavior between divide and, like basically, like I'm already doing an if statement for the divide by zero case, and now I need to do an if statement for the result. Like it's basically two completely different operations. So I might as well just do that. And is diff result used anywhere else? Because I guess I can remove that then. No. Yeah, so I think I'm just gonna comment this out too then. But anyway, so first we want to say if divide by 0, else if, so this is for division, so we want to say result negative, begin, and else begin end. So on this code is roughly the same. So we say result to Q equals all ones. If
if it's negative, we say result to Q equals negative div result. And then here we say result to Q equals div result. And so that's for division. And so then this will be for remainder. So then in this case, what we want to do, we still want to do a check for if divide by 0. The code there might actually not be right then too. In the case of like a divide by 0 remainder. So this is why I wrote that separate test code for the edge case. It's possible that the randomized test bench isn't actually testing that edge case. Yay! But anyway, so now here, so for divide by 0, so I think what I want to do is I want to keep track of result negative, or RS2 negative. So let's see, where is result negative stored? Here. RS2 negative. And so then here I just want to say RS2 negative if rstat itf dot rs2v width -1, yeah, whatever. And then here, this one I just always want to be 0. Yeah, so we note down the sign there, and then for divide by 0, what I want to do is, or actually, okay, so maybe I don't want to do this actually. Instead, I think what I'll do, instead of using a separate variable here, I'll actually just calculate at the start. So I'll just do this, and then I'll actually have result negative correspond to whether, or, because the thing is, like, I need to unnegate RS1 for a divide by 0, or a remainder by 0, because, yeah, remainder by 0, you just return the original x, whether it was positive or negative. So I need to note down that. And that's separate from whether RS1, see, RS1 negative, because whether the result is negative or not depends on the sign of the dividend. Oh wait, okay, wait, so
Rem and rem provide the remainder of the corresponding division operation. For rem, the sign of a non-zero result equals the sign of the dividend. Okay, now I'm actually curious. So if I go into Python, if I go into Python, what does it return? Like if I were to do 16, so 16 mod 5, or, yeah, okay, mod 6. 16 mod negative 6 returns that. Negative 16 mod 6, oh wait, yeah, Python has different semantics, I forgot about that. Python has the sensible semantics where I guess the sign, or I don't know, like Python has the sensible semantics where it like actually like the sign of the result is, I don't know, it's sensible. Or like, yeah. Actually wait, okay, so the math is a little bit strange here actually, now that I think about it. Because for the case for the division, you can just negate the output. But for remainder, you don't just negate the output. You have to like, you have to do like, you have to basically subtract the divisor, right? That's annoying. Let's see, so you have to, and so TC mode is fixed, right? Like you can't pipeline TC mode unless I'm, yeah, that's fixed. Let me just look at the data sheet for this again. Yeah, it's fixed. So you do have to do, yeah. So let's see. So for remainder, how does it work? Or I guess, okay, so we took the absolute value, right? So then for the remainder, we just have to negate. Okay, never mind. Yeah, so it is just like, yeah, you take the absolute value, and then you negate based on RS1. And I think that's also the right behavior. So the result sign always matches, yeah, so I don't think I have to keep track of it separate at all. So we just have a single result negative there. And then, so we'll get rid of these. And so then here, we want to say, if we're doing a divide, so itf.instruction.divrem, Yeah, so I think this is what it is. So you take result negative, and so I think I could actually probably just change this back to how the code was before. Yeah. Yeah, I could probably just change this actually back to how it was before. I think the issue was actually in how result negative was calculated. So all this actually, let's see. I think this should fix it. So basically the only change I made is now result negative for remainder operations is solely based on RS1 sign, which is the correct behavior. Because if you just think about like modular arithmetic, when we take the absolute value at the start for a negative operation or a negative RS1, you know, we negate it, and then we have to unnegate it in order for like the modular arithmetic to be, you know, like for it to be the same value mod RS2. Yeah. We love modular arithmetic. Yay, abstract algebra. Yay. And we're done. That was it. That was the last one. Well, let me run the test, or the mul test.s as well. What do you mean valid is unknown? What? How did it run the other test bench fine, but not the... Wait, like, really? So this one completed fine. That's great. Oh, no. No, it doesn't. Valid is still unknown at the very end. Yeah. Oh, why is valid unknown at the very end? See, because like this feels like, because the fact that it got through all the instructions means it's just like, I don't know, somehow the way it handles like the behavior at the very end it's not handling it correctly. Why would valid be unknown at the very end? That's strange. I mean, I guess it's because, like, maybe, like, the instructions it's fetching are unknown, and so then valid becomes unknown because of it. I mean, it should be halting, though, before... I don't know why it's not halting, unless I forgot to, like... Well, no, they should, yeah, they should both have the halt instruction at the very end. And I think this one even has, like, a decent buffer. I mean, maybe it's not quite long enough, but... No, it's only 5 instructions, but... Yeah. I mean, the code is still there, though, for... Well, also, okay, let me... Okay, so at least now that's out there. I guess, I mean, I might as well also run lint, just to make sure I haven't, like, introduced something here. But yeah, like, I mean, the issue is probably, like, it reaches the end of the instruction list, and then it runs the halt instruction, but, like, you know, by the time it would commit, like, by the time it would normally commit the halt instruction, it's already tried to, like, speculatively
I love
run.
casting.
Like, it's already tried to speculatively run,
Yeah.
a whole bunch of instructions after it, and all those instructions are unknown, because it's reading from, like, unknown memory. Yeah, I mean, I think this is actually the thing, because I think there's something in options.json that changes this. Yeah, bmem0 on x. I think we might want to set that to true, because, like, currently, like, while it's, like, speculatively, that's so strange, though. Why would that occur?
Don't know.
Like, why would RVFI valid be unknown at that point? I mean, I guess, like, why would RVFI valid become unknown when it's speculatively running instructions? Because that implies that the valid bit, or, well, it implies a couple things, actually, because let's see, how does the Rob compute RVFI valid? Committing, which comes from, so that depends on the head index, and the Rob done, and the valid bit, and not empty. Yeah, because, like, I mean, the contents of the instructions are the only part that's unknown. Like, you still have a known valid bit and whatnot. So then, most likely the reason why this would occur is, I mean, maybe if Rob done becomes unknown, for a given instruction. I don't know why that would occur, though. Because it's like... Because, like, basically the source of, you know, how do unknown instructions infect the control signals it's basically because like during dispatch, it switches between the different function units, and it does so based on which type of instruction it is. So if the type of the instruction is unknown, then so if the type of the instruction is unknown, then like which function unit it should go to becomes unknown, and then a lot that starts to infect all the control signals with unknown values.
No.
And then so that eventually goes on to affect like the CDB's valid signal. And then so the CDB's valid signal then affects CDB, so like CDB.rob index could become unknown, because it doesn't know which instruction it sent it to, or like which function unit it sent it to. So then the rob index would also be unknown. And so then, I don't know, I guess during X propagation it just sets all of the rob done values to unknown at the same time then at that point. Because it doesn't know which one to like set the rob index, like which entry to set the rob index. Or it doesn't know the rob index, so it doesn't know which entry to set rob done equal to 1, so it just sets all of them to unknown. Which then causes committing to become unknown, and then RVFI valid becomes unknown. I mean, I'm guessing if I were to just go in to options.json, change this to true, which I'm pretty sure we're allowed to do. I think the guide mentions it. bmem here specifies the value banked memory should return when loading from an uninitialized address, possibly necessary for various speculative memory execution schemes. Values, false, return X, true, return 0. So I think if we set this to true, we should be fine. And we're allowed to modify this file, so because we have to set the DWIP anyway. But anyway, so if I set that, this might fix it. We'll see. Oh, I'm in the wrong folder. Let's see, I can run make lint again. But yeah, because I mean, it's basically like unknown values are infecting all our control signals. So this is why they call, this is why one of the names for one of the types of undefined behavior within LLVM is called poison. Because it infects everything. It's poisonous.
I don't like poison.
Like, it's poison. Like, if I pull up the LLVM, if I pull up the documentation for LLVM, where is it? In here, it's poison. We love LLVM. LLVM is kind of fun to mess around with. It's a nifty compiler infrastructure. Yeah. There's three different types of undefined behavior in LLVM. Like, you thought one type of undefined behavior in C was fun, now try 3. Yeah, this document goes over it. Or there's actually kind of 4. You have like full-on undefined behavior, you have poison, you have undef, you have freeze poison, which I think is equal to freeze undef, and then you have a concrete value, which this is not undefined behavior, but like any of these other ones, kind of correspond to different representations of undefined behavior, namely like this is the strongest and this is kind of the weakest form of undefined behavior. Because basically like this one, which is immediate UB, basically the instant that instant UB occurs, anything can happen in your program. Like the compiler is free to do literally anything. Poison, it's like, I love info dumping this. I should probably actually work on the CPU, but I don't know. I love LLVM. I'm so glad I was forced to learn it. Because if I wasn't forced to learn it, I would never have bothered to learn it. It's like the same thing for Haskell. If I was never forced to learn it for CS 421, I never would have learned it. And now I enjoy it as a language. Or I don't know, it's decent as a language. There's some issues with it, but it's decent. Anyway, I was gonna go in sim and simulate the things. No, it still is unknown. Why does that happen? I mean, do I have to run make clean maybe? Let's see. So, yeah, I probably have to run make clean. Maybe that's it. Let's see, because I set that one to true. Yeah, let me try running make clean. Because like this specifically affects the block mem like HVL module. So it might not recompile it if you change options.json. No, it still is unknown. Crying? There's an actual issue? Crying? Why is it? Because the instruction coming in then is just all zeros, I think. Which, I forget what all zeros compiles to, but it should still get interpreted as a legal value. Or maybe not, actually. Yeah, that's annoying. It's possible that the all zeros instruction, like...
What do you mean valid?
It's possible that, like, the all zeros instruction is getting interpreted as something strange. Yeah, because, I mean, like, it doesn't match any of the opcodes that we use. And so because of that... So I guess maybe the solution is... Yeah, actually that might work better. Let me try doing that. So I'll set this back to false. And I'll go in here into decode. And I'll just set a default value for basically like which function unit it should go to. I guess I can do, I don't know, which function unit do I want to
These are
send it
things
to?
I've never thought to do to debug ever. This is crazy.
Let's see, because like we want all the control signals, even for like an unknown one, or I don't know, I might still need to, yeah. I might still have to set that value to true, because X propagation might still finagle with this. But anyway, so we want to set fu underscore type to some default ALU, for instance, and then yeah, I guess, yeah, we can just send it through the ALU, that's fine. But then we also need to set, Well, we set use to 0 for both of these. And then let's see, so where else do we get controls, like data infecting the control signals? Because that's generally something you want to avoid. Like ideally you don't let your data infect your control signals. To some extent it's unavoidable, especially when you have a processor that's designed like this. Or I guess it also happens like in MP pipeline as well with loads and stores, because then the type of the operand like affects it then. But anyway, so we want this to default to ALU, and what else do we want it to do? I think that's the main signal that we need to put a default for. So I'll just say leave a sensible default path for invalid instructions. Yeah, because I mean it generally is good for your processor to not freak out if it hits uninitialized memory, I guess. So yeah, I guess it makes sense to do that. But anyway, so we want it to go down the ALU path then, if it's an invalid instruction. And we have RS1 use set to 0 for an invalid instruction. And we don't care about the values that were read in for like from the PRF, so those can be unknown, that's fine. And we don't care, let's see, what else do we not care about? I mean, since used is set to 0, it's not going to wait for the CDB at all. And then since RD is set to, or RD used is set to 0, it's also not going to write to any of the PRFs, which is another thing that could happen. So I think that's probably sufficient. And then let me just make sure that the ALU actually checks the, okay, it does. So, yeah. Let's see, so that's set to false right now. I'm gonna see if it might still throw a fit about it, in which case I'll have to set options. I'll have to set that option to true in order for it to not complain. We'll see. Oh, okay, I guess that was sufficient. Just setting a default path for an instruction. I'm surprised that works, because like if the opcode is unknown, or I don't know, maybe I need to run make clean. Yeah, that might. Okay, let me run make clean first, and then I'll try running it again. And so this is false here. Right, yeah. Make clean. On this, let's see, we got 20 minutes before EWS kicks me out. Verdi is already closed at some point. Lol. No, yeah, that fixed it. Man, that's so insane. Just like, the valid signal is unknown. Let me fix it by setting the function unit type to a sensible default value, Ah, yes, this will fix it, and then it does. What the fuck? I think I understand what you mean, Indy. I think I'm starting to understand why why you're freaked out by how quickly I'm doing this. Anyway, does it work on the other case too then? Run it on this. Yeah, it does. No issues there. Cool. No clue why the IPC is so low. Well, no, I do have a bit of an idea. Cause like you need, cause like you know, there's that whole like, if we remember back to what happened with the fetch stage. Yeah. Cause like you basically need a really good prefetcher, and you definitely need to. Yeah, we'll definitely want to improve the fetch stage if we want to bump up our IPC. Because currently we're bottlenecked probably by the fetch stage and the cache and the like DRAM arbiter or whatever, or the DRAM adapter. I think that's currently our bottleneck. So for advanced features, we're going to want to improve that. Because ideally it should be feeding an instruction every clock cycle, but currently it doesn't because of mainly DRAM. Of course, there's probably other things that are slowing it down. But anyway, let's see. So it passes this test bench, which means all the edge cases for multiply and divide and remainder and all that work fine. Let's see, 110. Let me make sure that that's the right line for. Line 110. I don't even know what. I need to open it in Vim. Okay, yeah, so I did get through the whole thing, and there's no errors. Yeah. So I think what I'll do first of all is commit this. Yeah, it's so funny. It's just like a single line fix, and a completely like you would never think that like, oh, this is why my valid is becoming unknown. Like the only reason I was able to make that leap is like it's happening at the end of both of the test benches. Therefore, it probably has to do with like uninitialized memory. And then it's like, oh, it's probably like the uninitialized memory is giving an uninitialized instruction. And then because depending on the opcode, we send it to different function units. It's becoming it's like, you know, it's infecting a lot of unknown stuff there. So the fix just set a sensible default, and then that's it. Which I'm surprised that fixes it. Yeah, I'm really surprised that it does. Yeah. It's strange. Or like, okay, cause let me push this first, but cause like if so options is still like, this is set to false.
Yeah, so it works there, and then... Yeah, okay. I guess one thing that I should still test actually is out of order test. So that one ran fine. And so, let's see, what does this actually execute? So it does a multiply, and then a whole bunch of like adds, XORs, SLL, and none of which depend on the multiply at all. Okay. So then the idea is you pull it up in Verdi and show that like the other instructions complete first or whatever. Which actually, I mean, multiply completes somewhat fast because I think we only have 3 stages for multiply. We could always, I guess, go back in and increase the number of stages, which maybe I want to test that, make sure it still runs fine. But, yeah. But yeah, like this is the actual thing that they'll be checking, like, do you actually commit the instructions like out of order, I guess. So let's see if we do. Let's see, so the important thing is that we're able to commit like we need to be able to commit 040, like we need to be able to commit 044, 48, 4C, and 50, ideally after or before the multiply. So 40 is the multiply. 40, 44, 3C. Oh, so I think there still is actually an issue here where it's just like or 0. Or wait, no, I mean it's not what right, because it's always going to commit stuff in order. I forgot about that. Which I don't know if you actually need to commit in order. I don't know, I'm pretty sure RVFI lets you commit out of order. I might be wrong on that, but I don't know. Or maybe it requires you to commit in order. I don't know. But yeah, so like the important thing though is we need to show, I guess maybe by like either looking at the CDV or something or another. Probably the CDV is the easiest way to check. So like look in here. And
Yeah, so you can see like 4-0 goes on the CDB last. Yeah, so it is running all those out of order. Yay! Straight up out of ordering it. But yeah. So it's running that out of order. I feel like there was one other thing I wanted to check. What was it? Oh yeah, I was gonna try, I don't know, maybe increasing the number of stages in the multiplier just to make sure it still works. Yeah, I guess I could try doing that. Let me just make sure everything's committed. So if I were to go into the HDL, the function unit, the multiply, and just tweak the number of stages to be 30. I'm actually not sure how many. I don't know. What does the thing here say for number of stages? Oh right, I think it just optimal placement of pipeline registers within the multiplier to achieve maximum throughput. The pipeline can be stalled by setting the load enables to a load. It can either have no reset or an asynchronous reset or synchronous reset connected to the reset signal RSTN. Which one do we use? One synchronous reset. Wait. Oh, we currently have it set to asynchronous reset. You need to set reset mode to 2 for it to be synchronous. Yeah. So what are we supposed to... Like, where's the slides for this? So RST mode equal to 0. So make sure the parameter RST mode is equal to 0 for sequential. Or 1 for pipeline. I guess if I wanted to, I could pull out the one there. I don't know. I mean, we can change it later. Change that, it like messes up. Like having reset on that thing messes with the power so much. That's strange. Anyway, this thing's about to kick me out. Let me try running this with like 30 stages. Okay, that one still worked. That one still worked, and then multiply test.
That one still worked as well. Alright. Cool. Also, that's an interesting one. So the multiply test, I should actually look at the waveform. Maybe not when I'm about to be kicked out of EWS, but I should actually look at the waveform because like the multiply test is kind of special in that like there's no interactions between any of the instructions, like any of the multiply instructions, so it should actually fill up the multiplier pipeline. So that might actually be something to check. Of course, the divider is a different story because it's sequential, but yeah. Anyway, I think I'll close this for now though. Everything seems to be working, so I think we are good for this checkpoint. Good work, team. I don't know, Indy, did you make the progress report? Indy, are you alive, Indy? Did you fall asleep?
Oh.
So it's working. The whole thing's working.
What's our IPC at? Point.
Okay, well that's for the multiplier test, which that one's limited by the fact that we do like 30 divides back to back.
Yeah.
If you run rangen.s, I forget what this one gives. Let's see, so that one was 0.05. This one gives 0.192, which is not terrible. And I think the limiting factor at that point is actually the fetch stage. Like basically...
That doesn't sound too bad.
Yeah, because like, if you remember back to checkpoint 1, let's see, I closed, okay, I did close Verdi, because it's about to kick me out. Yeah, so I only modified that. Yeah, I wanted to test to see like if I set num stages to 30, does it still work? And it seems like it does, so. But anyway, like if you remember back in MP pipeline, or no, not MP pipeline, like checkpoint 1, when we had pop set to 1 100% of the time, so we were always popping from the instruction queue, it effectively followed this pattern of we got 1 DRAM burst worth of instructions, so 8 instructions, and then there was like a gap. So basically only maybe like a third of the time was it actually like being able to provide instructions. And so I mean we would have to look at, you know, we'd have to do some performance testing to see if that's actually what the bottleneck is here. But it's possible that it is to some extent that for this one. But yeah, not terrible IPC though. If I really wanted to, I should probably run this again, but with even more instructions. Because currently the randomized one was just with 10,000. Like I should probably run it on like 100,000 though, because sometimes there are things that only come up after like 60,000 instructions, just because they're so rare. But no, yeah, like I'm pretty sure our CPU works. It's able to get through at least all the stuff that I've thrown at it so far.
Sounds good.
And you know, like I tested the out of order test, like the one they provide, and it does like write back the multiply after all of the subsequent instructions, so you know, it's out of order. But yeah,
I love out of order.
we love out of order processor.
Wow, you have a working. Ooh.
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 But yeah, hopefully you enjoyed the debugging montage.
No, I don't, like, my debugging montage is like, I stare at it, I look at it, and I don't think about why it's not working. I just think about just tracing it back all the way to the beginning. I'm just like, okay, I still don't understand anything.
Yeah, it would be impossible to like fully trace through how these programs run on the CPU. It's
You're too good. You're just too good.
It would be impossible to fully
watching
trace
from
it
the
through.
beginning is just like, it's like art.
Yeah, like tracing everything that happens in the processor is impossible, so you have to like selectively look at stuff, and it turns into like a puzzle or like a detective game.
I love detective game.
Yeah. You know, because it's just like you poke it, see how it responds, and then make some more educated guesses, and eventually you narrow it down to where it's happening. But it's definitely helpful. It's definitely helpful having that RVFI struct pass through the whole thing, though. I'm glad that one, I looked at the lab slides, and two, I noticed that they recommended that.
Yeah.
Because, you know, and also like passing the instruction type all the way through to the function units, that's also helpful. Because like having that within the reservation station is nice. It gives you a little bit more context for what instructions are stored in the reservation station. But
Good stuff. That was really good. I think I might try and break it, like, while if you're gonna go away, I think I might write my own test and see if I can break it at all.
Okay. I mean, if you want to, you can also look at the Python script, read through it, generate like 100,000 instructions, and see if the thing supports it. I did leave, like, within the help text for the script, it does say like, yeah, these are the options you should use for this checkpoint, namely, you know, the no AUI PC option and the -M option, which enables multiply extension.
Good stuff.
But yeah, I don't know. It's not that complex of a program. It's just it's a Python script. So if you want to read it,
Okay. Yeah. No, I'll check it out sometime.
Yeah. Yippee. They kicked me out yet? Oh, I'm still in. EWS hasn't, or the engineering IT services or whatever the department's called. They haven't kicked me out yet. How long until they kick me out?
Oh my gosh. You did it before that. Congratulations.
Yeah, I managed to get it in before like before I got kicked out of EWS. Yeah. But yeah. Oh, hey, there it goes. Let's see. Oh, this one, maybe it's already kicked me out. Yeah, because it's only once I type into it that it actually like recognizes. I mean, I could probably even log back in. I don't know. We can test it more later. I think it's probably here. What I'll do. I'll see if it lets me SSH back in. Okay, cool. And I'll try running like 100,000 instructions because it runs decently fast. So, let's see. I'll just restore the change I made there. But yeah. So I do. So it's -M, no AUI PC, -N, I don't know, 100,000 If I really wanted to, I could like run 1,000,000, but yeah, let's do 1,000,000. See what happens. It's gonna take a while for it to finish, but just leave it running. Leave it running overnight. Let's see. So then I want to go in sim, make clean, make run VCS.tv. Alright, now we just leave this running and see what happens. Alright, there we go. 10,000 down. What was that? 990,000 more to go. Hopefully this doesn't spit out another bug. Yeah. Or another deadlock even. Man, like for like MP3 of like the compiler construction course, or not MP3, MP4, we have to implement like register allocation as like, you know, like a compiler pass. And like generally, like at least one approach for it is basically, because like the problem that register allocation tries to solve is the intermediate representation within the compiler of the program uses like an infinite number of registers, but the target machine only has, say, like 32 registers. So register allocation is just assigning those like virtual registers to like the 32 like machine registers. And the funny thing is, like, it's MP complete in general. And so the technique is basically like you try to run it, and then if it fails, you insert some additional like loads and stores, basically put some of the local variables onto the stack, and then you run it again. And then you put more stuff on the stack and run it again. And like that's just how it's implemented then. It's definitely interesting looking at like the RD values, because it's like most of these are either 0 or -1. You know, because like theoretically they should be like a random sampling of the instruction results, and it's like most of them are actually either 0 or 1, which is kind of interesting. I mean, I suppose it makes sense because it's like, I don't know, you run AND, you run multiply. I mean, it almost makes you wonder, well, I mean, the immediates keep it from just like falling into like some fixed point. Yeah, because the immediates, like, you know, add in these like random amounts, and the load up are immediate instructions too. So yeah, it's definitely interesting though that most of these are just zeros and one, like either all zeros or all ones, with the occasional exception. I guess one could like argue like, what are the merits of you know, like, is this a good distribution of values for testing? Probably, because I mean, most of the time when you run code, all the values are small. So is this good for testing edge cases? Maybe. Maybe not. But I mean, you could argue that it is because, like, it's hitting these edge cases of 0, 1, -1, etc. But yeah. I mean, it doesn't hit all the edge cases, though. Like, it doesn't hit, like, the minimum int value and whatnot. It's kind of interesting because you can actually take guesses at, like, what instruction caused some of these values. For instance, like, left shifts are pretty obvious to spot, especially, like, if it's a left shift of, like, an all ones value, like -1. Like, those ones are pretty obvious to spot. I suppose they could have come from multiplies as well, but yeah. Yippee. Halfway to 1,000,000 instructions. All this going well. So, yippee. Yeah, so we can't run core mark or any of the other stuff yet. Yeah, we don't have branches or load stores, but yay. Yeah, definitely the forwarding. Some of the forwarding paths are definitely weird though. Like, especially that one to, like, the dispatch, like the register in dispatch. And I mean, one could wonder, like, should we have more registers in dispatch? Maybe. I mean, because, like, if there's a critical path there, you can always just add more registers and then let retiming handle it. Like, basically just insert a queue somewhere if there's timing issues. And I mean, there already is a queue though, so it's like, well, it can't be a regular queue. It has to be a like, it can't be the circular buffer based queue because that won't cause retiming to kick in. Retiming only kicks in if you do just like a shift register type queue. Then it kicks in. Yeah.
Oh, 7, 6, 5, 4, 3, 2, 1. Oh, 1 million instructions. No errors. I don't know. I think that's probably sufficient testing. I'd say. I don't know. 1 million instructions. How big of a file is it? Let's see. Test code. Rangen.s. 21 megabytes of assembly. Lol. Does that count as running like a million lines of code? 21 million lines of code? I guess. What happens if you pull it up in Vim? I'm gonna regret doing this. It's gonna freeze. It's gonna... Oh? Hey! Look at that. Vim is somewhat fast. Even for large files. Yeah, look at that. So many... all the instructions. Anyway. Cool. Send main. Alright. Okay. Yippee. Oh, wow. And they didn't even say it. Oh, you're bad. Alright, I sleep. Oh yeah, progress report. Indy, did you write a progress report? Indy? You there?
Oh, I've been muted. Oh,
Did you write a progress report? Did you put
I
it
wrote like,
in the drive or something? Or...
oh, I guess like, here. I wrote a little bit of it, and then when I mean a little bit, I mean like a really tiny bit,
Yeah, that's fair.
because I was just, oh, there you go. Oh, let me give everyone access. All right, there you go.
Yeah, I don't know if I would even bother writing the new file section, because that's like... it's a pain to like list off all those new files and like document every single one. We can, but...
I'll write it. It's fine.
yeah. If you want to. I think the main things are like... I don't know, what are the main design decisions? I guess like...
Let's see here. See here.
I might just put some other notes in here too to see like anything I can remember about like important changes that we had to make. Arrays of instances are a pain. Might be better to just use structs in the future. Yeah, arrays of instances are a pain. What else was there? Because I mean, like a lot of the time was spent just like on kind of syntax and like system Verilog constructs. Like I'd say it was almost like equal parts, you know, fixing the actual logic of the code and just like fixing like the synthesizer not liking certain things. So yeah. But yeah. What other notes were there? I don't know. What other notes can I think of?
Um, what else is there? We have the ready bit. What else was there? What other notes are there on it? The design decisions. I guess there's Um, what other ones caused a deadlock? What were the other causes of deadlocks? It was. The what other deadlock causes were there? I guess those. So there was deadlocks caused by incorrect division code, and deadlocks caused by. I think these were the main ones. Like there was that forwarding path. There was that one. Man, this is just like 385. Or which class was it where like we had to list out any bugs that we hit while writing it? I feel like that might have actually been 391. We had to like list the bugs as they occurred.
Too many.
Yeah. But yeah, so I think the last one was just the stall caused by division being, or actually, technically these are the only ones that cause deadlocks. I think, like I managed to fix one of the bugs with like the values that division computes early, thinking that it might have been the cause of a deadlock, but it actually wasn't the cause of a deadlock. It was something else. Because the same deadlock on the same instruction was still happening even after I fixed it. And I think that one turned out to be, I don't know. It might have, or maybe it was this one. I don't know. Or maybe it was this one. It was one of the two. It was basically two bugs that caused deadlocks. So, let's see, did I mention? What other bugs were there that were of note? I think these were all the main ones. Yeah, because like there was still all the usual like, oh, you misspelled something, oh, you know, like there's all those syntax bugs. Those weren't particularly notable though. Yeah. But yeah, what else is there? I feel like there's more bugs and I'm forgetting what they were. I guess I could just take a look at like the missing rvfi ref.json. I guess I could get log -diff. No. You can do that. I guess you get. I thought there was a way to do get logs that outputs the full diff. Oh. Get log full diff. There we go. Oh. Never mind. it still doesn't change it. How do you output the full diff? Yeah, generate patch. Yeah, there we go. So there was that one, there was... Oh, right, I don't know, I mean, is it possible?